Hello everyone, welcome to this interesting video on Blockchain Developer Full Course. In this video, we will explore all the important features and concepts revolving around blockchain, starting with what is blockchain, who is blockchain developer, how can one become a blockchain developer, what are the applications of blockchain, and why does it matter. Then, we will understand the complete mechanism and architecture of blockchain. Following that, we will explore some of the most important concepts of blockchain, like what are hyperledgers, cryptocurrencies like Bitcoin, Ethereum, Dogecoin, and towards the end, we will have a look at the comparison between them. We will then conclude this video by discussing the essential interview questions and answers to help every individual clear an interview with full confidence. By the end of this video, I can assure you that all your blockchain career-related queries would have been answered. For this training, with me, I have experienced blockchain specialist Rahul and Saurabh. Together, we will take you through the various important keynotes of blockchain. So let's start with an exciting video on Blockchain Developer Full Course. Before we begin, make sure to subscribe to our YouTube channel and hit the bell icon and never miss an update from Simplilearn.
Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine 4 friends, Jack, Ted, Sam, and Phil, meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Phil sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then, Ted and Sam send their respective shares to Jack, but their transactions don't go through. The failed transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank, one of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional charges, like transfer charges, associated with transferring money. To solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on a technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash, and so on, one reigns supreme: Bitcoin. Now, let's go back to our previous example and have Phil, Ted, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Phil, Ted, and Sam have 3 Bitcoins in reserve, while Jack has 5. First, Phil sends 2 Bitcoins to Jack. A record is created in the form of a block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So, after Phil's transaction, Jack has 7 Bitcoins, while Phil has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records, or blocks, is called a ledger, and this ledger is shared among all the friends, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Phil has only 1 Bitcoin left, and he tries to send 2 more Bitcoins to Jack? The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Phil has only 1 Bitcoin left. His friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using cryptography. Now, let's have a closer look at the Bitcoin transaction between Jack and Phil and find out how it works. Every user in the Bitcoin network has 2 keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of, something like a password. First, Phil passes the number of bitcoins he wants to send to Jack, along with his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Phil's unique private key. This is done to digitally sign the transaction and to indicate that the transactions came from Phil. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. While Bitcoin uses the SHA-256 algorithm, Ethereum, which is also a famous cryptocurrency, uses one known as Ethash. This transaction and several other similar ones are taking place all around the world. These transactions are validated and then added block by block. The people who validate these blocks are called miners. For a block to be validated and added to a blockchain, miners need to solve a complex mathematical problem. The miner who solves this first adds the block to the blockchain and is rewarded with 12.5 bitcoins. The process of solving the complex mathematical problem is called proof of work, and the process of adding a block to the blockchain is called mining. With this, Phil and Jack's wallets are updated, just like every person in the network who has completed a transaction. Now that you know about blockchain and its important concepts, time for a small quiz. What is the concept of blockchain that ensures data cannot be altered by any of the users within the network? A. Public distributed ledger. B. Proof of work. C. Proof of stake. D. Hash encryption. Let us know what you think is the right answer in the comments below. Let's have a look at how Walmart uses blockchain to provide its customers with better service. Walmart was facing problems in delivering quality products to its customers. They were facing a high return rate and large amounts of refunds due to their product's bad quality. They were unable to determine the point of failure in the supply chain, which started from farm to storage to transportation to processing all the way to the customer. Then, Walmart adopted blockchain technology. With blockchain, the quality of the goods at each step was permanently inscribed within a block. For example, when a customer flags a product as damaged, it can be correctly identified where the product got damaged in the entire supply chain, thus helping Walmart to identify the problem areas and fixing them. And this is just one of several ways blockchain is used in real-life application.
Ray is a tech-savvy guy and loves to spend most of his time exploring the web on his laptop. One fine day, he was going through an article on futuristic gadgets, and suddenly, he noticed an ad for the PS5 popping right beside the article. He found it a little strange as he recalled searching for that just a few hours ago. Later that day, he came across some suggestive ads popping up related to buying future-leading gadgets. And that is when he freaked out, thinking, how can it be possible that what he was searching for just a few hours or days ago on the internet is now suggesting ads related similar to them? So he thought of going to his elder brother Aaron, who is a software engineer in an MNC. Upon understanding the situation, he explained to Ray that all of this is happening because we are in an era of Web 2.0. It all started in 1994 when Web 1.0 was introduced to the internet. Basically, Web 1.0 was all read-only content that was not interactable and was similar to a huge Wikipedia page. But after a few years, in 2004, Web 2.0 came into the picture. Web 2.0 made the internet much more interactive because of developments in web technologies such as JavaScript, HTML5, CSS3, and others, which allowed companies to create interactive web platforms like YouTube, Facebook, Wikipedia, and many more. He further added that when we seek out information or data of any kind from any web platforms present on the internet, simultaneously unknowingly, we also provide them with information related to our choices and interests, which are stored in cookies, which later they sell to various companies who make use of this data to advertise exactly what you are looking for. And this is how Ray was able to see ads of his concerned interests. Ray was fascinated by how the internet has evolved and how it works amazingly. But at the same time, he he was concerned about the lack of privacy offered by it. Ray, out of his concern, asked Aaron, "Is there any way that one can get rid of the loopholes of the current Web 2.0? When Aaron answered yes, there are a lot of ways to do that, using Tor browser, incognito mode, etc. But these are not permanent solutions, and there can be fluctuations in their reliability. But this scenario can be changed not just for you, but for everyone using the internet, with the help of Web 3.0. Ray was curious about it and asked, "What is Web 3.0? Aaron explained that Web 3.0 is the next step in the evolution of the internet, allowing it to process data with near-human intelligence through the use of artificial intelligence and blockchain technologies that run innovative programs to help users by providing them with their relevant choices. It's a significant step toward open, trusting, and permissionless networks." Aaron further added, "To fully comprehend this, we must first explore the 4 key features of Web 3.0. First is decentralization. Blockchain will help decentralize data storage while also establishing trust in the virtual world. Because Web 3.0 allows information to be retrieved based on its content, it can be kept in several locations simultaneously, making it decentralized. This would dismantle the vast databases currently maintained by internet giants like Facebook, now Meta, and Google, giving more power over people. Second is trustful and permissionless. Web 3.0 will also be trustful and permissionless, which means that participants will be able to interact directly without the need for a trusted intermediary or permission from a governing body. Due to this, you can access any data relevant to your choice without any permission from any other node or third party. For example, if you are researching for some data, you don't need to accept its cookies, or you don't need to provide any sort of details, as there is a trustful bond between you and the web. Third is artificial intelligence and machine learning. In Web 3.0, through technology based on semantic web ideas and natural language processing, computers will be able to understand the information in the same way that people do. For example, "I love Paris" and "I heart Paris" may seem different in syntax. However, their semantics are nearly identical. This will help the user to achieve more relevant content to their choices and will provide them ease with internet browsing. Fourth is connectivity and ubiquity. In Web 3.0, the internet will be accessible to everyone, anywhere, at any time, because IoT, Internet of Things, technology will launch in several new smart devices. These internet-connected devices will no longer be limited to PCs and smartphones, as they were in Web 2.0. Understanding the shortcomings of Web 2.0, corporates like Amazon, Apple, and Google are transforming their existing services into Internet 3.0 apps that abide by these 4 principles. Siri and Wolfram Alpha are 2 applications that use Web 3.0 features. After learning about this, Ray was relieved by the fact that Web 3.0 is going to bring so much of a difference, not just in his life, but also to the society as a whole. So, here's a question for you. How is Web 3.0 related to blockchain? A. It helps create smart contracts for web pages on the internet. B. It helps Web 3.0 store its data in the blockchain. C. It offers a decentralized experience to its users. D. All of the above. Please take a minute to think about it and leave your answers in the comments section below. Web 3.0 will offer a more personalized and customized surfing experience, and a smarter and more human-like search assistant, and other decentralized benefits, all of which are believed to contribute to a more fair web. This will be accomplished by giving each user control over their data, resulting in a richer overall experience. In a nutshell, the internet will become considerably more intertwined in our daily lives when Web 3.0 arrives.
Let's get started with who is a blockchain developer. A blockchain developer is a person who is responsible for developing and hence enhancing blockchain-related applications, famously known as dApps, smart contracts, architecture, and protocols. For those who don't know what blockchain is a system of recording details of transactions in a block taking place in the blockchain network. That makes it difficult or impossible to change or hack, which means they are immutable. A blockchain is essentially a digital public ledger of transactions. that is copied and distributed across the entire network of computer systems on the blockchain. Basically, blockchain developers enable secure digital transactions by creating systems and applications to record and store blockchain data and prevent external changes or hacks. That brings us to what are the types of blockchain developers. There are two types of blockchain developers: core blockchain developers and blockchain software developers. Each type has its specific type of role. Let's go through them in more detail. The core blockchain developers design the protocols required to run a blockchain solution successfully, which means they are majorly responsible for the architecture development of blockchain. They are also responsible for designing consensus protocols and making high-level decisions. Blockchain software developers develop and implement the blockchain using the designs and solutions created by the core blockchain developers. They are majorly responsible for designing and implementing smart contracts and developing decentralized applications or dApps. Now let's understand what are the technical skills required to become a blockchain developer. To become a blockchain developer, you need to have a specific set of technical skills. Let's take a look at them. Understanding blockchain architecture. For starters, you should have a complete understanding of blockchain technology, its architecture, how it works, and its critical concepts like hash functions, distributed ledger technology, and consensus protocols. Next, data structure and coding. Data structures and coding are considered the most basic and essential skills required to be a fine developer. It is a must-have skill to become a blockchain developer, as it enhances your ability to play and configure blockchain according to your requirements. Development of smart contracts. Smart contracts is the most vital part of blockchain technology. The programming language Solidity is used to create smart contracts. Ethereum is the best example for smart contracts. It helps you set up the business and develop and deploy dApps using smart contracts. And at last, basic knowledge of cryptography. Blockchain secures its data by using highly effective cryptography algorithms. Cryptography helps you implement dApps and other blockchain services. Now we have covered the technical skills required to become a blockchain developer. Let's explore the roles and responsibilities of a blockchain developer. Both core blockchain developer and blockchain software developer have different roles and responsibilities. First, we will discuss the roles and responsibilities of core blockchain developer. Core blockchain developer understand and implement the features and functionalities of blockchain. They design protocols and consensus protocols for blockchain networks. They create solutions for providing security to the data stored in the blockchain network. And they make sure that the blockchain network functions smoothly and securely. Now, blockchain software developer design and implement smart contracts. They develop and deploy decentralized application or dApps as per the requirements. Also, they look after the integration with other applications and services. Now let's dive down and explore the companies hiring blockchain developers. There is a massive demand for blockchain developers, and if you know your skills well, you will surely get a good start with your career as blockchain developer. Joining a programmers community and working on real projects will help you learn, grow, and upskill yourself. According to 2021, SignSoft, a software development company, Ripple Labs Incorporation, an American technology company that deals with the Ripple payment, Leeway a software development company for startup and enterprises, Chromaway, a blockchain technology company, OpenLedger, a decentralized financial platform used to convert bitcoins to smart coins, and IntellectSoft, a company specialized in providing software products and integrated solutions, are a few top companies who hired blockchain developers to work on blockchain technology. Now that we know about the demand of blockchain developers worldwide, let's figure out the average salary of a blockchain developer in both the USA and India. In the USA, the average salary of blockchain developer is over $157,000 per year. And in India, it ranges from 5 lakh rupees to 30 lakh rupees per year. So this is all about Who is a blockchain developer?
Hi guys, I'm Rahul from Simplilearn, and today I'm going to tell you how you can become a blockchain developer. Now before we begin, let's see the current situation of the market. 84% of companies are now dabbling into blockchain. Blockchain is the fastest growing skill in the US freelance job market. Apple's Steve Wozniak is getting involved with blockchain projects, and JP Morgan's CIO believes that blockchain will replace existing technology. As we can see, with the amount of focus organizations are putting on blockchain and what tech influencers around the world have to say about it, we can see clearly that they really believe that blockchain can have a tremendous positive impact on our lives and the market as a whole. So it's no surprise that blockchain has worldwide acclaim now. It's created a huge number of job opportunities across the world. And one such job is that of a blockchain developer. So here's what we're going to learn today. Who is a blockchain developer? What are the types of blockchain developers? The steps you have to follow to become a blockchain developer? The obstacles you might face while learning blockchain? The salaries offered to blockchain developers? And how companies are using blockchain right now? So, who is a blockchain developer? A blockchain developer is someone who designs, implements, and supports a blockchain network. So in a way, they are responsible for setting up the blockchain network and then ensuring that it works properly. They create and optimize blockchain protocols. For example, is the network a public network? They create such protocols and then optimize it based on their usage or requirement. They develop distributed applications and smart contracts on the blockchain network. Now, let's talk about the different types of blockchain developers. So they fall under two major categories: core blockchain developers and blockchain software developers. A core blockchain developer works on the core features and the architecture of the blockchain network. Basically, they're in charge of the entire blockchain network. They manage the architecture of the network, supervise the blockchain network. They work on consensus algorithms. For example, there's the proof of work algorithm in Bitcoin, and set up blockchain protocols. A core blockchain developer works very much like a core web developer. Now, the main thing is that they both work on core concepts. Now, just like blockchain developers work on protocols, you have web developers working on protocols like HTTP or TCP/IP and so on. Now, let's talk about a blockchain software developer. Now, they work on blockchain to create applications. Now, they create smart contracts, develop distributed applications, and work on the front and back end application development. Blockchain software developers are also very similar to web application developers. Both of them create applications on a network that's already set up by core developers. So how do you become a blockchain developer? So before you start off on your path to becoming a blockchain developer, there are some things that you really have to know. Now we're going to talk about the prerequisites. First up, you have programming languages. Now, it is absolutely necessary that you be well versed in programming languages before you can get onto blockchain development. Most blockchains are created in languages like Java, C++, JavaScript, Go, Python, C#, and so on. So let me emphasize how important it is that you know programming languages. Now, for core blockchain development, any of these aforementioned languages will do the job for you. However, in case you have to create distributed applications and smart contracts on Ethereum, it is mandatory that you learn the programming language Solidity. Then you need to understand the fundamentals of object-oriented programming. Now, the concepts of object-oriented programming, which anyone who codes will know, is the wrapping up of data and functions into a single unit. This is exactly what blockchains function on. For example, you have the Ethereum block here. It has two components, data and function. The user details act as the data. Now, this data includes the person who's sending the transaction or how much money they're planning to transfer. Then you have the function, which is the command to send and receive payments. Then you need to learn about flat and relational databases. Now, blockchain was created on the basis of these two types of databases. A flat database stores data in a single table structure, and a relational database uses a number of tables and can cross-reference records across tables. So it is necessary that you understand how these two databases work to completely understand how blockchain was created from their concepts. Then you need to learn what data structures are. You need to understand the working of data structures like stack, linked list, queue, and so on. This is because blockchain by itself is a backlinked list. Each block in a blockchain references the previous block. Now, this is done by a field in the block's header known as the previous hash that holds the hash value of the preceding block. Knowledge about web application development. By being well versed in web app development, you're opening yourself to a wide range of opportunities to create web and mobile applications using blockchain technology. Because regardless of whether the application works on blockchain technology, the front end can be created only with web application development. Then you need to know about networking. Blockchains work on the internet. So you need to understand the many concepts regarding networks. For example, how systems are able to communicate with each other, how the network works, and so much more. Now, after you're done with all of this, you're ready to start your journey to become a blockchain developer. The first step is to understand the concepts of blockchain. Now, Satoshi Nakamoto's white paper, Bitcoin, a peer-to-peer electronic cash system, gives a detailed account on how Bitcoin works and introduces us to the concept of blockchain. So if you want to learn firsthand how blockchain works from the creator of Bitcoin himself, I would suggest you go to Satoshi Nakamoto's paper. Next, you need to learn important terms related to blockchain. For example, what is a miner? What is a block? What is a public distributed ledger? Hash encryption, proof of work, mining, and so much more. Then you can learn how systems other than Bitcoin like Ethereum, Hyperledger, Hashgraph, and so on use blockchain to work with their technology. The second step involves understanding the economics behind cryptocurrencies and blockchain. Blockchain technologies work on crypto economics, which is nothing but the combination of two words, cryptography and economics. Cryptography in blockchain involves hashing, digital signatures, and proof of work. Hashing is involved in maintaining the privacy of a user within the network. This is made possible with the help of cryptographic algorithms. For example, in Bitcoin, we have the SHA-256 algorithm and ETH in Ethereum. Digital signatures help validate a particular user within the network. This is made possible with the combination of the user's public and private keys. Proof of work involves miners around the world trying to solve a complex mathematical puzzle to be able to add a block to the blockchain. On the economic side, you need to understand how miners are incentivized. The users who add and take part in the blockchain are given cryptocurrencies. Now, people who take decisions also have the right to charge a fee for their service. For example, if a person has a block and he has to decide what transactions he's going to add to that block, he has the right to charge you some amount of money if you want your transaction to be added to his block. Good users of the network are rewarded with monetary compensation or the ability to take decisions. Bad users of the network have to pay a fine or have their rights to take decisions stripped away. Step 3 is to understand how cryptocurrencies work. With cryptocurrencies, there's a whole number of steps before a process is complete. You need to understand how each and every step works. For example, first, how a sender begins the transaction to send money to the receiver, how the message is encrypted and transmitted across the network, how miners are able to verify that transaction, how the block is added to the blockchain, how money is deducted from each of the participants' wallets. You need to understand the relationship between each and every step of the process and how they interact with each other. Step 4. Getting some hands-on experience. Now, after you're done with all the steps that I mentioned before, this one's the hardest, practical application. So even if you know all the theory, if you don't have any practical experience, it won't have a very large impact. So you need to start coding and creating your own smart contracts. You need to create your own distributed applications on the Ethereum platform. Also, let me remind you, for you to be able to create smart contracts or distributed applications, you need to have learned the programming language Solidity. And finally, you can invest in Bitcoins or other cryptocurrencies so that you can have an understanding of how they actually work. Now, it's very important that you also keep yourself updated regarding cryptocurrencies and blockchains and Bitcoins by reading up on blogs and forums. You can take part in Discord chat rooms. You can use the Telegram application, which has a very active community on cryptocurrencies and blockchain. You can involve yourself in subreddits like r/blockchain, r/bitcoin, and other related subreddits. You can get on CoinMarketCap that talks about market capitalizations of several cryptocurrencies, CoinMarketCal, and so much more. There's an abundance of resources on the internet that you can take advantage of. Now, let's talk about the obstacles that you might face while learning blockchain. Now, you've noticed that blockchain isn't very easy. There's a lot of content to cover. Now, to make matters worse, you could also face some of these problems. First of them is outdated content. Now, the tutorials and content that you might find online cannot possibly keep up with the constantly changing technology. So it's only natural that the content that you might get might be a little outdated, which isn't what you want. You want the latest and the most highest quality content. Secondly, lack of quality content. Now there's an abundance of sources that you can learn from. And since there's such a wide variety, it's possible that you might end up using a type of source that's of low quality or of substandard quality. Now, let's talk about salaries that you can get in a blockchain job. Now, in the United States, blockchain developers earn $130,000 per annum according to Burning Glass Technologies. In the more tech-oriented areas of US like Silicon Valley, New York, and Boston, they earn up to $150,000 per annum. Several companies around the world have invested heavily into incorporating blockchain into their processes. Now you have companies like Alphabet, Bank of America, Wells Fargo, Apple, Microsoft, and so on. So this is a clear indication that companies are very interested in hiring people who are skilled enough in the concepts of blockchain. And finally, how are companies using blockchain? Walmart uses blockchain to keep track of each and every step in the supply chain. With this, they are able to track down where the problem area is and to ensure that that problem is solved before it can happen again. You have JP Morgan Chase & Co. This company created their own blockchain application called Quorum that solves the processing that allows private transactions to take place in a group of participants whose identities are known. The Agricultural Bank of China created a loaning system using blockchain that aimed to help small and medium-sized agricultural businesses that didn't have a good credit record. Now, how can Simplilearn help you? Simplilearn provides certification courses that give you an introductory or an advanced understanding into the concepts of blockchain. The Introductory Blockchain Basics course provides 12 hours of self-paced learning and covers all the concepts related to Bitcoin and blockchain data structures. Moreover, it gives you an introduction into blockchain, Bitcoin, blockchain mining, buying and selling Bitcoins, emerging trends in blockchain, and so much more. Now the advanced course or the blockchain certification training course provides 32 hours of instructor-led training, 50 plus hands-on exercises using blockchain technology, 9 practical projects covering Ethereum, Hyperledger and Bitcoin, case studies, and so on. It also helps you understand Solidity programming, Ethereum coding, advanced smart contracts, Ethereum application architecture, real-life projects, and so much more. The content of these courses are constantly updated to keep up with emerging trends in the market, and it is of highest quality. So now let's have a look at supply chain management. Now let's look at a scenario before blockchain. So there's a delivery boy bringing John his order of apples. Now John thanks him and sees that his apples are rotten, and John says that he wants his money back. However, the delivery boy says he can't help since he's just the delivery boy, not the person who created the product. So these problems are the ones that were faced before blockchain. But with blockchain technology, there is traceability across the supply chain. This means that you can trace back to what happened to the product at each step of the supply chain. Blockchain technology enables these transactions to be tracked in a very secure and transparent manner. Now, some benefits of using blockchain technology are that there's a single record policy, which means there's a single record throughout the entire supply chain. There's reduced costs since there's no requirement for multiple records across the entire supply chain. There's eliminating error and less human intervention. Now, the last 2 points come somewhat in correlation since the lesser the human intervention, usually the lesser the amount of error. Let's have a look at an example of a supply chain management. So the product starts from the farm, goes through storage, undergoes food processing, it's manufactured, distributed, given to the retailer, and finally reaches the customer. Now, in supply chain management, blockchain is able to provide a permanent record, a whole lot of transparency, and the ability to validate the transactions that are shared across multiple supply chain partners. With blockchain, the transactions are recorded in a decentralized distributed ledger. Now, the advantage of this is that anyone can verify the authenticity or the status of a product that is being delivered. Now, if you want to look at a real-life example, you have to look no further than Walmart. Walmart is building a blockchain distributed ledger so that they can connect and track pork suppliers, manufacturers, shippers, purchasers, and other units involved in its supply chain that are delivering the food product across China. Now, this is done to reduce the risk of data tampering or inaccuracy. Now, let's have a look at how blockchain helps cybersecurity. Imagine the scenario where A is sending $20 to B. A sends this money and this transaction details are stored in the cloud. Now, what if a hacker hacks the data within the cloud and tampers this? He tampers this in such a way that he receives the $20 instead of B. Here you can see the hacker being all smug about it. Now, this is the main problem with the current banking system. Now, it is prone to cyber attacks because it has a centralized network. This can also lead to fraud as well as data theft. Cyber attacks are one of the biggest threats that the public has to face. However, blockchain is a solution that makes sure that your data is protected from tampering as well as helps improving cybersecurity across a number of different industries. Some of the benefits are that it provides high security with the help of the cryptography that I mentioned before. It has a decentralized storage, quick transactions which take only about 10 minutes, and lower cost as compared to banking transaction costs. Now, let's look at the same scenario but with the help of bitcoins or blockchain. Now, A is sending 0.0025 bitcoins to B, which amounts to approximately $20. These bitcoins are sent, and blockchain, which is a distributed ledger, distributes the data across multiple nodes within the network and secures this data using cryptography. Another thing that you have to remember is that each node has a copy of the ledger, and cryptography protects the data within it against any changes, making it immutable. Now, imagine a hacker trying to hack the data here. He's unsuccessful because the peer-to-peer connection which prevents data from being altered as well as tampered. Now, and finally, B receives the $20 in bitcoins. Now, for a real-life application, MasterCard has its own blockchain project where MasterCard is using blockchain for sending as well as receiving money. It also allows the exchange of currency without the need of a central authority. Now, let's have a look at how blockchain can help with the voting process. Now, before blockchain, a voter would have to submit their voter ID. Their voter IDs need to be verified, and after the verification, the voter would submit his or her vote to the EVM or the electronic voting machine. After that, the voting is complete. However, it is possible for the EVM to be hacked since it's a centralized system. This can lead to some amount of manipulation with the vote count. However, with a decentralized system like blockchain, it is possible to completely eliminate any scope of forgery as well as data manipulation. Now, let's have a look at how voting can be performed with the help of blockchain. Now, first, the voter downloads a voting application. The voter submits a voter ID and registers for the election. After the verification is complete, the voter has been authorized to cast his or her vote, and the voter submits his or her vote without revealing their identity to the public. Now, once this vote has been added to the blockchain, the information within the blockchain can never be erased. After this, the officials can count these votes, knowing that each ID can be attributed to just one vote. Now, with blockchain, voters can also count the number of votes themselves. Using blockchain in the voting process provides complete transparency by eliminating any need for third-party systems to be involved. Along with that, it can also eliminate voter fraud as well as election rigging. It increases the transparency in the voting process and reduces the expense of conducting the elections. Now, in real-life examples, MeVote, which is a token-based blockchain platform, works very similar to that of a digital ballot box. Now, it protects the integrity of the vote as well as protects the security of the election process. Now, this is already implemented in Australia, so it's only a matter of time before this or similar technologies can be set up across the world. Now, let's have a look at some of the other applications. There's insurance, where with blockchain, they can eliminate forgery as well as false claims, and real estate, where this increases the speed of the conveyance process and eliminates any requirement for money exchanges. So if talking about blockchain and its applications have caught your interest, I suggest we get on to Simplilearn.com and check out our blockchain certification training course. Here we provide 50 hours of in-depth learning, 40 plus hands-on exercises with integrated labs, 11 practical projects covering multiple technologies like Ethereum, Hyperledger, multi-chain and Bitcoin, flexibility to choose your own class timings, case studies, and 24/7 support. We'll be covering technologies like Git, Ethereum, Ganache, Go, Docker, Hyperledger, and much more. We'll also be talking about Bitcoin blockchain, Ethereum, deploying smart contracts, Hyperledger, blockchain or multi-chain, and a whole lot more. So why don't you go on to Simplilearn.com and get started on your journey to getting certified and getting ahead.
I think blockchain is going to be a very critical technology for the future development of the world. It's not only about the financing. Blockchain technology is not about Bitcoins. Bitcoin is just a small function of the blockchain technology. I'm a strong believer of the blockchain technology.
This is not about Bitcoin or digital currencies or crypto assets. It's the underlying blockchain technology. Now people can trust each other and they can transact with anything from money to music to votes to their identities peer-to-peer.
Bitcoin is either MySpace or it's Facebook, I don't know. But blockchain is social media. So at the macro, blockchain's going nowhere, right? Like blockchain's here to stay forever, and it's a very big deal.
Enter blockchain. Satoshi Nakamoto, 2008, anonymous person, came up with this way of people transacting, doing business with assets peer-to-peer. And trust is not achieved by a middleman. It's achieved by cryptography, by collaboration, and by some clever code. And what that means is that we now have a native digital medium for value.
Effectively, it's software.
Okay,
I mean,
so
it's a distributed database that's managed independently, and that inherent combination makes it a utility, makes it software effectively that has value and utility.
The business world of the future, say 10 years from now, is going to run on smart contracts. It's going to run on strong encryption and on, peer-to-peer based consensus mechanisms. So the core technologies underlying blockchain are going to pervade everything, just like the internet has, just like object-oriented software has, right? No.
So the choice, when I talk to people, I said, what do you think will be here in 2040, approximately 22 years from now? Will gold still be here? Well, it's been here since eternity.
Well,
will the dollar be here?
Right.
I don't think so. And will blockchain be here? I think so.
We think of Bitcoin as a digital gold, so gold 2.0, but it's money, the first step of money that was ever built purposely for the internet. So it's sort of like what your email did to snail mail. Cryptocurrency or Bitcoin does for money.
Well, Bitcoin is exciting because it shows how cheap it can be. Bitcoin is better than currency in that you don't have to be physically in the same place. And of course, for large transactions, currency can get pretty inconvenient. The customers we're talking about aren't trying to be anonymous. They're willing to be known. So the Bitcoin technology is key, and you could add to it, or you could build a similar technology where there's enough attribution that people feel comfortable. This has nothing to do with terrorism or any type of money laundering.
It's still very early. Institutions, everybody knows about it, everyone's heard about it, and there's some very sophisticated people in even these banks who know about cryptocurrency, but they're still not really in the game yet. It's still very much a retail-driven market, very much a lot of the actions out in Asia. So we still think it's the bottom of the first inning. If you read this book, you understand how we got here and how far it's come, but it's also just sort of the beginning in a lot of ways.
Well, I think it is working, and there will be other currencies like it that may be even better. But in the meantime, there's a big industry around Bitcoin. And people have made fortunes out of Bitcoin. Some people have lost money out of Bitcoin.
It's volatile. It's volatile.
Yeah, but it is quite volatile. But when in volatility, people can make money out of volatility.
So where I see crypto as effectively as a replacement for cash, but not as a replacement as a primary. I do not see crypto being the primary database.
I would say there's a lot of need for developers even at the core protocol layer. So things like improving protocol scalability, working on the client implementations of things like proof of stake. Layer 2 systems, things like state channels and Plasma could probably use a lot more smart people. On the application stuff, I mean, I guess you could always use more, but there's probably quite a lot more of that already.
Welcome to this session of Blockchain Tutorial Part 1. My name is Saurabh and I am part of the Simplilearn team. So let's get started and understand what's in it for us today. So let's take an hypothesis. In a city not so far away, somebody was up to something bad. So there is a hacker who hates the bank, who wants to steal the money of all the people lying in the bank. Now, here's why I hate them even more. What are the nuances and the problem areas of the banking system? The banking system has higher transactional and international transfer costs. A lot of documentation is required for setting up of an account, for opening an account and onboarding a customer. And the banking system is not always accessible. It's not 24/7. It's closed on banking holidays, and it has other limitations also, like transfer limits in a day, and you can't transfer X amount within a stipulated time. Now, banks in such an ecosystem acts as a center point of failure. It is a centralized based system which is prone to failure from a centralized point of view. So if the bank fails, all the transactions will come to an halt which are dependent on the bank. Now let's see what happens if the hacker is able to get into the banking system and hacks the bank. All the investors or the people associated with the bank, the information associated with them will get corrupted, will get jeopardized, and it can lead to huge losses to the bank and to the individuals. And all this can happen with a click of a button. It's as simple as that. So once a hacker has access to the system, he can manipulate the system, compromise the information, share it with the parties which are not supposed to have that information, and lot can go wrong. Though the hackers can be caught, right? It is possible through cyber security and various means. But once the information is compromised, it is very difficult to roll that back. And that's why we need more secure systems and systems which are not dependent on a centralized authority, which work in a more decentralized fashion, thereby making it hack proof plus lowering the transaction cost also. Now, this incident, of course, will catch the bank manager's attention. Now, he will go to his advisors and want to make sure this does not happen again. So, the technology people, the advisors will make sure that this does not happen. But what is the remedy? So, the remedy is setting up a blockchain. Now, of course, the manager who's looking into the banking functions might not be aware of the technology and what benefits blockchain bring onto the table in order to prevent such an incident. So that's what we are here for. We will learn before we go and understand what can blockchain actually achieve for us. So we will understand today what is blockchain, the Bitcoin story, the features of blockchain like public distributed ledger, the hashing encryption, the proof of work consensus algorithm, and the concept of mining. And then we will cover up a use case where how blockchain can be used for banking operations. Now, what is blockchain? Blockchain is a list of records called blocks which stores data publicly and in a chronological order. And the entire information is persisted using cryptography. It is secured using cryptography. So cryptography ensures that the privacy of the user is maintained and data cannot be altered. Information on a blockchain network is not controlled by a centralized authority. So unlike modern financial institutions, nobody controls the data within a blockchain. The data is maintained by the participants of the network, and they are the democratic authority in order to approve any transaction which can happen on a blockchain network. Access to anyone on the network. So a typical blockchain network is a public blockchain. So as long as you have access to the network, you have access to the data within the blockchain. If you are a participant on the blockchain network, you will have the same copy of the ledger which all other participants have. So therefore, every participant on the network has the same copy of the data. So everyone in the network has a copy of the blockchain data, which is used for ensuring that data remains untampered. So even if one node or data on one particular participant computer gets corrupted, the other participants will come to know immediately that this particular instance or node has gone corrupted, and they will rectify it as soon as possible. So basically, the question is this the same technology that Bitcoin works on? And the answer is yes. Bitcoin could not have been possible without blockchain. So we will understand how Bitcoin adopted blockchain in order to reach to its journey today. So Bitcoin was introduced in 2009 by someone or a group of people known as Satoshi Nakamoto. It aimed to solve the problem faced by fiat currencies with the help of blockchain technology. Now, as of today in 2018, there are more than 1600 cryptocurrencies that follow the concepts of Bitcoin and blockchain. For example, the other popular cryptocurrencies are like Ethereum, Litecoin, Dash, Ripple, and many more. Now let me explain how a Bitcoin transaction works. The sender transmits the transaction details worldwide. Basically, whenever a sender has to do a transaction, he has to send Bitcoins to a receiver. He will submit the transaction on the public blockchain network of Bitcoin and transmit it. Now, verification to authenticate users, it is done by the miners around the world. So basically, there are specific participants in the Bitcoin network which are called as miners, whose job is to verify the authenticity of the sender and the receiver, and also validate whether the sender has the right amount of balance for the Bitcoin which he is trying to send to the receiver, and ensuring that the sanity of the underlying blockchain network to the Bitcoin remains correct and not get corrupted. So once the miner has authenticated the transaction, verified all the parameters, the transaction is added to a block, and then that block is made part of the main blockchain. Once the block is added to the blockchain, the money, the transactions which were associated in the block then gets executed. Money is deducted from the sender's wallet and is added to the receiver wallet thereby. Once the transaction is completed, the block is added and the ledger across all the nodes are updated. Each and every participant ledger copy is updated with that particular block which has been added in the blockchain. So therefore, all the participants have the same copy of the information. Now, so what makes blockchain special? Now, these are the special 4 features of blockchain which we're going to talk about in detail. It is a public distributed ledger. It works using a hashing encryption. Each and every block has a hash value, which is the digital signature of the block. All the transactions are approved and verified on the blockchain network using proof of work consensus algorithm. And the blockchain network utilizes the resources of the miners who are there to validate the transaction. And the miners, in lieu of investing in their resources and validating the transactions, get rewards in terms of Bitcoin, and that process is called mining. Now, public distributed ledger. So let's imagine 4 friends sharing a particular document amongst each other, correct? Now, if there was only a single copy of that document and one of them altered the data, it may go unnoticed. However, the outcome would be different if each one of them had a copy of the data. So therefore, if each and every participant has the same copy of the data, even if one of them changed the data, the others would find that the data does not match with their own. So blockchain works in a similar fashion. The data within a blockchain is accessible to everyone. So with this, as long as you are part of the network, you could access the entire history of transactions that have taken place since the blockchain was created, since inception. And the first block in any blockchain is called the Genesis block. So from the Genesis block to the current block, you will have the access to the entire chain. Any additions to blockchain have to be approved by the participant users in the blockchain network. So a majority of the members within the network have to approve of any additions to the blockchain. This is the public part of the ledger, and this is important because any additions made to the blockchain are permanent and are immutable. So immutable transactions are the transactions which cannot be altered. Once registered, they cannot be modified and are available for audit and verification 24/7. So this means that each and every detail is recorded and any alterations can be detected by verifying it against everyone's personal version of the blockchain. So if someone's tried to modify a data on a block on a particular node, then the other ledgers which are having the same information will come to know that someone has modified data on a one particular node and they will try to rectify it. And the fourth property, no central authority is controlling the working of this blockchain network. It is a decentralized network. So this is where being decentralized helps. Everyone has a copy of the blockchain, which means there is no central point of failure. There is a single source of truth. Even if things go wrong, the data can be recovered. If one node goes wrong, the data can be recovered from other nodes. But what about security? How is privacy maintained if everything is so public? And here hashing encryptions comes into picture. It takes care of that. So now we will talk about the second feature, which is hashing encryption. But to understand hashing encryption, we need to understand the contents. What are the contents of a block? So a block in a blockchain is like a container that holds aggregated transactions. It contains certain set of transactions. So we will see what all things construct a particular block. So a block has two parts. It has a header and it has the second part is the transaction details. It is the set of transactions which are aggregated in this block. Now the header has following set of attributes. It has the block version number. It has the hash of the previous block to which it is linked, the current timestamp, the timestamp at which the block was verified, the nonce, we will see what is the attribute, what is the meaning of nonce, and the target value. Now, the transaction details are nothing but the example which we talked about earlier. It is the transaction which the sender and receiver are sharing. The sender is trying to send certain amount of Bitcoin from his account to the receiver's account. Now, it is represented in the form of a 256-bit hash value in the header called as Merkle root or the hash root. So basically, the Merkle root is the hash of all the transactions structured in a Merkle tree called binary tree. It's a kind of a binary tree, and the hash value of the root node of the Merkle tree is called the Merkle root hash. So the transaction details of a block are contained in the header in a hex value known as Merkle root. The Merkle root can be calculated in this way. So basically, the list of transaction, each transaction is passed through a hashing algorithm. Then all the hashes of the transactions are paired and then again passed through another hashing algorithm until only one value remains, and which will be the root. Now let me tell you how a hash function works. Blockchain utilizes a hash function to perform cryptography. Data from a data set of random size is sent as input to a hashing function to get an encrypted value of fixed size. And that is the feature of any hashing function. So some unique properties of hashing function are, these are deterministic. The same input will always produce the same hash output. Small changes in the data can drastically change the output. Basically, any small change to the input produces an output that's drastically different from its previous obtained outputs. It can be computed easily. The output values can be obtained without a whole lot of calculation, and hashing functions are one-way functions. Basically, you won't be able to determine the input based on the output value. So you can't do the reverse calculation. Now let's go back to our block we were talking about earlier. So as we were discussing, what are the features in the header? The previous hash is the resultant hash of the previous block in the blockchain. And this is the way two blocks are linked together. Now, transaction details, these are used to provide details about the sender, receiver, and how much money they want to exchange between them. And this is a list of transactions, and they are structured in a Merkle tree, and the hash of the Merkle root is put in the header. Nonce is a value that is varied to create a unique hash address of the block, which should be less than the target hash value. So this is the structure of the header. It has a block version number, basically the sequence number of the block. It has the hash of the previous block, the timestamp when the block was mined and verified, the nonce value. The header is then, this entire header is then passed through a hashing algorithm. In the case of a Bitcoin network, it is SHA-256, and a hash value is generated. And now this hash value becomes the hash value of the block. Now this value is a 256-bit value that is used to uniquely identify the particular block. So SHA-256 ensures that alterations to data can be easily detected. So for example, consider these two blocks in the blockchain. They have a similar structure and definitely different hash values. Now, if someone alters the transaction details in the first block, the corresponding hash value of the block would change too. Now, the values of hash value of the first block and the previous hash value of the other block will not match. Basically, the block subsequent to the hacked block will get delinked. Now, this will raise an alarm among the users, informing them that data alteration has taken place. The users will then be able to flag the block, so the alteration can be easily identified and rectified immediately. To ensure security, blockchains also include digital signatures. These ensure that the message comes from the right identity, right person, and that the message is not tampered with. Users are provided their own private and public key. So whenever a user onboard a public blockchain, he is provided a pair of public and private key. Now, private key is used by the user to control her own account. This is kept as a secret by the user. So basically, it is like his own password. And public key is used to identify the user on the network. This is shared by the user along with the transaction on the network for others to verify. So these are the steps involved in creating and authenticating a digital signature. So at the sender side, the message to be transmitted is passed through the hashing algorithm. In this case of Bitcoin, it is SHA-256, and the hash is generated, plus the private key is used to generate a digital signature. Now this output is passed through a signature algorithm along with the user's private key to create a digital signature. Now during the transmission, the user's message, their digital fingerprint, which was generated in the previous step, plus the public key are transmitted across the network. So these three things are published on the network for the validators, for the miners to use and verify the authenticity of the sender. Now at the receiver's end, first the message is passed through a hashing algorithm. Now at the same time, the sender's public key and his or her digital signature are passed through a verification algorithm. Now both the functions will generate a hash. If both the hashes are compared and if they match, then the transaction and the identity of the sender is approved. Otherwise, it is rejected. So basically, this is the process by comparing the hash values to authenticate the identity of the sender. Now, what about the people who verify these transactions, and how do they actually do it? So remember that one field in the block header called nonce, that becomes very important in order to verify the transaction. So now we will talk about the third feature, which is the proof of work consensus algorithm. So proof of work involves people around the world, the participants in the network called miners, competing to be the first one to add a block to the blockchain. And in lieu of this, they will be rewarded. There are competing miners around the world. They are trying to solve a mathematical puzzle to be the first one to be rewarded and to add a block to the blockchain. So this is the reward. So thereby they invest in the computing power, they invest in the resources in order to mine and validate a transaction to get that reward. Now, what is the mathematical puzzle? So basically, they need to find a hash value that satisfies certain predefined conditions. Now, in order to find the hash value, they will use nonce. So this target hash value is decided months in advance for every block. The miners keep variating the nonce value to find out an output that falls within the target requirement. So they keep on generating a hash value using the nonce, and if it is less than the target, the hash value is accepted, and if it is greater, then the hash value is rejected. The miner's effort is not considered valid. Now, a miner transmits across the world that he has found a nonce that satisfies the target requirement as soon as he finds it. And thanks to the hashing algorithm used, this claim can be easily verified by others. So basically, the proof of work algorithm, it is very hard to generate the nonce and get the hash value, but it is very easy to verify the transaction by the other miners. So that's a whole lot of work. What a miner's payoff is. So for all his or her hard work, they get paid in the bitcoins, and this is the only way the bitcoins get added to the network. Sometimes they get other forms of remuneration as well, and this is the concept of mining. So the entire process, when the miner has done the proof of work consensus, they are rewarded, and this is called as mining. So mining is the process of adding a block to the blockchain. This miner is the first person who found a nonce value that fell within the target requirement, right? Now for doing this, the miner is rewarded. As of today, on the Bitcoin network, a miner is paid 12.5 Bitcoins for adding a block onto the blockchain. But the reward a miner gets reduced by half every 4 years. So when the 4th year will approach, for the threshold, the Bitcoin reward will go down to 6.25 Bitcoins. And the miners also get the sum of all the transaction fees for that particular block. So the 12.5 Bitcoin reward is justified as mining is a very expensive process. It has a heavy toll on electricity, computing power, and other resources on which the miner has invested. Now we will take a look at the use cases where blockchain is applicable in banks. So we have been incorporating a program where banks can validate user identity. As of now, a user needs to do the process over and over again in each bank. He has to go and prove the identity in each bank. Is there a way we can ease the process with blockchain? And the answer is yes, we can. We will be using Truffle, Ethereum, Ganache, and smart contracts, all of these blockchain technology ecosystem to make it work. And welcome to this demo for how to build your KYC blockchain application. Now I'm gonna show you all the steps required to deploy your KYC application, what all components are to be developed, and how to go about deploying and testing your application. So primarily this KYC application will allow banks to do a decentralized KYC of the customers which come to their banks. So in the demo we will see when a customer walks into the initiating bank, will do the KYC for a customer, enter its details and verify it. And if any subsequent bank wants to use the KYC done by another bank, he or she needs to take the permission of the customer, and then he can use the same KYC for verification. So we will see how can we do that. So just to start off with, we have developed a KYC solidity contract which has all the necessary functions in order to do the actions required for doing a KYC of a particular entity by the bank. Now once this contract is ready, we will be placing it in our sample Truffle package. So this is my Truffle package, and in this I have the contracts folder. In the contracts folder, I have kept my kyc.sol file. Now in the command prompt, I will compile my contracts. We can ignore the warnings. So here is my Ganache client which I have just started, and in my Ganache client, as you can see, it is running on port 8545 and it has already given me 10 accounts pre-funded with 100 Ether. Now I had already mentioned that my Truffle is connected to localhost 8545. So now when I'll do my Truffle migrate command, it will connect to my Ganache and deploy my KYC contract. So now I can go to Truffle console, and for me it's very important to see at which particular address my Solidity contract has been deployed. I'll copy it, and in my UI code under root.js contract details.js, I will make the change of this address where my contract has now been deployed. Now, after doing these steps, my application is ready to interact with my Solidity contract, which is being deployed on my local blockchain network. Now, as you can see, when I deployed the contract, this is my primary account from which the ethers were deducted in order to deploy the contract. Now, there are certain steps in order to get the application up and running. So first we need to sign up the banks. So suppose I say bank 1 and the password should be the first address of the bank. So basically we are associating one bank with one account which we have on our Ethereum network. So we will sign up. Now bank 1 is successfully registered. So now in order to log in, I can check Now bank 1, I have logged in. Now I need to add a KYC for a particular customer. Now after filling the basic details, I will create the customer, and the username I have kept as customer1. Ideally, this is the unique identity of the customer. It can be any social security number or the Aadhaar number or any unique identity which is attached to the customer or the email ID and can be used as the unique identifier for the customer. Now once customer profile is successfully created, we need to log in as a customer to allow this bank to see the KYC details. Now suppose if I say customer 1 and search it, it is saying access denied and take the permission from customer to proceed. So before the bank can do the KYC complete, the customer need to approve it. So I am creating the credentials for the customer. Now customer can see his details, whatever were filled by bank 1, and he can see that there is a request from bank 1 to allow to view his KYC. Now before we allow, I will also create another bank, bank 2, and associate it with my another address and try to log in with it. Now bank 2 is also logged in. Now bank 2 has not done the original KYC, right? But it is trying to look up and its access is also denied. So it needs to explicitly take permission. So the bank will take explicit request from the customer. So now the customer has request from bank 1 and bank 2 for the KYC. It is up to the customer whether he or she wants to allow and deny the KYC request. After the permission has been granted, then only the banks can be able to view the KYC. So if I say bank 1 allow and bank 2 deny, now all the requests are done from the queue. So bank 1 was allowed and bank 2 was denied. So if I again log in with bank 1 and the password is my first address, view KYC customer 1. So here it is, the bank 1 is able to see the details. Now if I log in as bank 2 and give password and try to see it is saying permission denied. So let's ask bank 2 to again request. Now bank 2 is now again requesting and now this time it allows. Now bank 2 can see the details. So all these transactions in the backend are happening on the blockchain network, which is interfacing with the contract through its subsequent methods. Now the primary details of the contract are in the contract details.javascript, where we have to provide the address at which the contract was deployed, the ABI file, the ABI. So you can get the ABI at here. This is the ABI and you can paste it here. And this is the binary data, which has to be pasted over here. So the binary data can be fetched from Remix. This is the binary data for the contract, which has to be copied and pasted over here. Now with these essential inputs provided, our application allows us to interact in a decentralized fashion to access the KYC records of a particular customer. Now we can modify the details also, and we can add a new customer again. So this is a basic demo of how a typical KYC application works in a banking environment. So hey, thanks for coming back to explain how blockchain work. Now let's talk about the features of blockchain. Is a public distributed ledger, It uses a hashing encryption to encrypt all the information on the blockchain. It uses proof of work consensus algorithm for a consensus mechanism, and it works with the concept of mining in order to reward the miners for keeping them and maintaining the sanity of the network. And finally, about how you can implement blockchain in a banking system. So we talked about how to implement a KYC based blockchain decentralized app and how it allows you to create a decentralized banking system where a KYC done by one bank can be leveraged by another bank, and the customer does not have to go through multiple KYC iterations with each and every bank whom he or she wants to transact with. Now we will get a little deeper into blockchain, and today we will talk about these topics. We will talk about what is a candidate block. We will talk about Byzantine fault tolerance, which was one of the earlier consensus mechanisms. Then we will talk about the problem of if we have to add two blocks at the same time, then how does blockchain handles that? Then we will talk about the concept of forking, what are soft forks, what are hard forks, and other areas where blockchain is getting used, what is the future of blockchain, and what are the upcoming blockchain jobs and the profiles which are upcoming in the market. And then in the end, we will do a quick demo on how to create a smart contract and deploy it for a particular use case. Now, before a block can be mined, a miner has to make a very important decision. Which transactions would be added to his block? So before transactions are added to the blockchain, they are collected in a temporary container called a memory pool. The miners select transactions from this pool and they put it in a temporary block called candidate block. So basically, the candidate block is a temporary block which a miner hopes to add to a blockchain. It's a candidate to be added to a blockchain. So the candidate block holds transactions that the miner selects from the memory pool. The miner then tries to be the first person to find the nonce value that satisfy the hash requirements. Now the question comes, if someone in a blockchain wanted to input the wrong data by spreading wrong information around, would he or she be able to get away with it? And that's why we had something known as Byzantine fault tolerance. So in order to maintain the sanity of the network and to have the correct consensus, there was something called as Byzantine fault tolerance consensus algorithm. To understand this, you need to know what the Byzantine general's problem is. So let's imagine a Byzantine general and three other lieutenants need to take over this town. However, they are at different places and can't directly communicate with each other. So here we have the general and his three lieutenants. The general has to ensure that all lieutenants follow the same order he or she gives them to attack or to retreat. Now, this has to be ensured even if one of the lieutenants is a traitor. So this is the Byzantine general's problem, that how does the general communicate the correct decision which he has taken to all his lieutenants in his network, irrespective if someone is a traitor. In this case, a traitor could ruin the unity of the group by sending different messages to different lieutenants. Now here we can see that general is giving all his lieutenants the command to attack. The traitor could ruin this by sending every other lieutenant the command to retreat, the opposite. Now in this situation, the traitor would make others believe that the general asked them to retreat. So as we can see, the lieutenant in brown is the traitor, and he could communicate to other lieutenants the wrong information and make them act on his behalf as a traitor themselves. Now this would cause the lieutenants to retreat and the general's attack to fail. So how do we tackle this? The only way an attack or a retreat will be successful is by having a majority supporting that particular action. To achieve this, the lieutenants keep a tally of the orders they receive. So in this scenario, the general sends the attack order to each of his lieutenants. The lieutenants in turn collect the order they receive and pass it on to the lieutenant near to them. So each lieutenant will pass this order to the nearest lieutenant. The traitor also will do the same, but sends the retreat order to the other lieutenants. However, this will not be successful because each lieutenant now has a majority of attack and minority of retreat. So this shows that the majority of the lieutenants would follow the general's command and the attack will be successful. The scenario I mentioned before is Byzantine fault tolerance. Now the same situation can be encountered in blockchain as well. The traitor would add invalid transactions into the blockchain. The traitor would send the inconsistent information to other nodes in a blockchain. This would affect the reliability of blockchain and network. Blockchain are able to achieve Byzantine fault tolerance with the help of proof of work. Let's see how it is effective. It is effective because the process of adding a block to a blockchain is a work-intensive process which involves a hashing algorithm. The process is very hard, very computative because it is heavily reliant on value obtained from the existing blockchain. To have any meaningful impact, the hacker would have to take a lot of time, resources, producing sufficient proof of work. Interesting. Imagine if you and I were miners and we both add a block to the blockchain at the same time. How do we handle such a situation? So although this does not happen very often, there is a way to decide whose block should be added to the blockchain. In an ideal scenario, you just need to be the first one to find the hash value. You need to be the first miner to generate that hash value and win the block. So adding two blocks at the same time, the hash value of the block only needs to be within the predetermined limit. If the generated hash value is less than the target, then the value is accepted and the block is added to the blockchain. But if it is greater than the target, then the value is denied and the block is not added to the blockchain. But in this case, if two people have obtained a satisfactory hash value at the same time, so miner 1 and miner 2 were able to find the hash which was less than the target, then what will happen? Whether miners 1 block will get added to the blockchain or miners 2 block will get added to the blockchain. Now, 50% of the network has accepted miners 1 block and suppose rest has accepted miners 2 block. So half of the network continues to work considering miners 1 block to be the right block and the other half network continues to work considering miners 2 block to be the right block. However, only one miner's blockchain can be allowed to remain. We cannot have two blockchains running. It will defeat the purpose. Now, this is achieved by selecting the subchain to which miners have first added a block. So suppose miner 3 adds a new block to miners 1 blockchain. This block now added by miner 3 is verified by everyone in the network. It is then accepted as the dominant blockchain and is used by everyone else in the network. The other version of the blockchain, the miner 2, is completely discarded and the entire network now accepts miner 1's blockchain and we have now a single blockchain existing. Now this situation is also called an accidental fork. So I heard about a version of Bitcoin called Bitcoin Cash. What's the difference between them? There are other kinds too, like Bitcoin Gold and Bitcoin Private. These are all outcomes of a fork. So what is a fork? A fork is said to have taken place when a blockchain diverges into two potential paths. A fork happens when the users of a network cannot come to an agreement with regards to a network's transaction details and the new rules to validate those transactions. So there are two types of forks which can exist. Either it can be a soft fork or it can be a hard fork. A soft fork occurs when a change in the software protocol makes new blocks added to the blockchain following the new rules but are backward compatible. But in order to have a soft fork, it requires a majority of the users to commit to that change to be successful. So a soft fork could have multiple uses. It could be for tighter rules, it could be for cosmetic changes, addition of new functions, but not affecting the structure. So consider the scenario where the accepted block size is to be reduced from 1 MB to 100 KB. So first of all, it has to be approved by a majority of the network. Now the old version will be running on 1 MB block size, but once approved, the new version will start working on a block size of 100 KB. So anything which is less than 100 KB will be approved and will be added to the new block. So over time, people following the older version of the blockchain would be forced to move to the new one since none of their transactions would go through. So basically people using the old blockchain, they will be using the 1 MB block size, their transactions will not succeed and they will be forced to use the 100 KB block. Now let's talk about hard fork. A hard fork involves a change in the software protocol so radical that it forces a new blockchain to be created altogether. So basically in a hard fork, there will be two versions. There will be one blockchain that hasn't upgraded and there will be a blockchain that has upgraded according to the new software protocols. Both these blockchains will be considered valid and legitimate. The new path would follow new updated rules while the other one keeps following the old path. So the old one will not be discarded and will remain into existence. Now, Bitcoin performed a hard fork on 1st August 2017, which created Bitcoin Cash. So thereby both Bitcoin and Bitcoin Cash remain existent. Now, Bitcoin Cash was different from regular Bitcoin because it increased the block size from 1 MB to 8 MB. So thereby it helped reducing the transaction cost significantly lesser than that of the original Bitcoin network. Now, other than with Bitcoin, where else is blockchain used? The other areas are for preventing voter fraud. Blockchain helps in ensuring that there is only one vote per person, ensuring that the data is not being tampered with or any false alterations are done. It helps creating an immutable ledger to record the votes as tallied. So once a transaction or a vote is recorded, it cannot be modified. It is also used in quality assurance, ensuring the products are of highest quality, being able to identify problem areas easily. So where do you think blockchain is going to be used in the future? So blockchain is seeing wide range of adoption amongst organizations. As of now, only 1% of all organizations have begun using blockchain technologies, but this percentage is expected to increase in the next 5 years or so. Then there is a need for blockchain regulations. The rules and regulations surrounding blockchain are not very clear for organizations to be comfortable using it and move towards faster adoption. Also, there is a need for removing the negative speculations surrounding blockchain. Several industries fear that blockchain will disrupt their normal functioning and believe that the adoption of a blockchain system isn't worth the effort. And there is an increase in job opportunities for skilled personnel. So as the technology is maturing, there would be a huge requirement for individuals who can understand and implement the concepts of blockchain. So what options do people have for jobs involving blockchain at the moment? There are many job opportunities, but the two most famous ones are blockchain architect and blockchain developer. Blockchain developer is a profile which requires designing, implementing, and supporting a distributed blockchain network, analyze user requirements, design technology around a certain business model to build and launch a blockchain network. Blockchain architect profile requires to design and architect blockchain industry solutions, creates blockchain networks leveraging blockchain technology platforms, produce high quality code based on project requirements, conceptualize, design and build blockchain frameworks and assets. So let's have a quick demo on how to deploy a rating smart contract and have decentralized application running on a local blockchain network. We will be using Truffle and Solidity to build this application. So in order to build this application, we should have installed Truffle and Ganache on our local system. So this is a Ganache client which is running on my local host. It is running on port 8545 and network ID 5778. Whenever you run a Ganache client, it is preceded with 10 accounts and 100 Ether balance. Now, this is my movie rating app, and in this app, I'm going to deploy a smart contract called rating.sol, which is going to capture the ratings for a certain set of movies, which I'll predefine, and the users will be able to set the ratings on a blockchain network in a decentralized fashion, and we will be able to see that in every transaction, a block is getting generated in my Ganache client. So in my movie rating app, under the rating folder, I will run the command truff compile, and it will compile my smart contract rating.sol. Now, the next command which I have to run is truff migrate. Now, at this instance, the truff migrate command will deploy my smart contract on my Ganache client. So if you see, there are 4 blocks which have been created, and my contract was created in this transaction, and this is the address of the contract at which my contract is deployed. So I can go back to my command prompt and say truff console and check the address of my contract. So this is 0x695, which is this address. Now when I deployed my smart contract, I had given the entry of deployment in a file called deploycontract.js under rating migrations, and in that I had given this entry. I had given the path to my rating solidity file, and I had initialized my smart contract with 3 movies, Star Wars, Avatar and Inception, and given some predefined gas. Now once these steps are done and I know the address at which my contract is deployed, I will copy that and paste it in the file of Ethereum setup.js, which is lying under my rating app UI source folder, and I'll just change this address. Now once this rating address is changed, I have to go back to my movie rating app folder. Under app UI, I have to give the command npm start. Now my application is up and running on localhost 3000, and as you see, I'm able to do the voting, and at each rating level my block is going to increase. Block 6, Inception, block 7, and as and when my rating is increasing, a block is getting added. So this demonstrates the usage of Truffle and Ganache in order to build your decentralized app.
Hyperledger and its importance. Hyperledger. Hyperledger is an open source collaborative effort created to advance cross-industry blockchain technologies. It is a global collaboration hosted by the Linux Foundation, including leaders in finance, banking, Internet of Things, supply chains, manufacturing, and technology. It is a framework to create, deploy, and maintain blockchains for businesses that ensure accountability, transparency, and trust among business partners. As a result, Hyperledger makes business networks and transactions more efficient. Concept of Hyperledger. Now, before I tell what Hyperledger is, let me tell you what Hyperledger isn't. Hyperledger isn't a blockchain, a company, or a cryptocurrency. Hyperledger is a software used to create one's own personalized blockchain service. It is basically a project within the Linux Foundation, just like several other projects under them, which include Node.js, AllJoin, DroneCode, and Akumos. Since it is open source, people across the globe can come and help develop and grow the platform. Restrictions in public blockchain. With a goal in mind to develop an enterprise-based blockchain platform, developers started testing interactions between applications and secure blockchains and realized that public blockchains require each peer to validate transactions and run consensus. This is a major challenge when it comes to scalability. Moreover, the transaction confidentiality and privacy was also getting lost as every node in the network was receiving a copy of the ledger. Private and confidential contracts. Let's consider an example. A certain bank is giving better privileges to its premium customers, for instance, in credit cards. Thus, if I am a premium customer of the bank and have been banking with them for quite some time, then it will give me a better offer on credit cards or will give me a loan at discounted rates. These things are common in the banking world. However, if these banks start using public blockchains which have complete transparency, disparity like these will become evident. Moreover, there is an issue with regards to competition. All banks are competing with each other in order to create a better place for themselves in the market. Thus, they want their confidential information about transactions and other operations to stay completely confidential. This won't be possible in a public blockchain like Ethereum, which stores all smart contracts on public ledgers. This is where platforms like Hyperledger come into the picture, which permits permissioned and private transactions, and it is highly scalable as a platform. Solution to the restrictions. On Hyperledger Network, only parties directly related to the transaction deal are updated on the ledger, thus maintaining privacy and confidentiality. Hyperledger primarily leverages the concept of channels to ensure privacy and confidentiality. A channel is basically a virtual blockchain network which sits atop a physical blockchain network and has its own access rules. They employ their own mechanism for transaction ordering and thus ensure scalability, thereby permitting effective ordering along with the separation of data. In the above example, when John and Kat are conducting a transaction, a private channel between them serves as a method of interaction. The smart contract can thus be viewed by only these two parties, and the network's endorsement policy verifies their membership with the network to ensure privacy. Thus, the transaction is secured and private and confidential. Hyperledger transaction. In the above example, John is initiating a transaction to send a message to Kat. Let's assume that we have a state in the ledger named as message, denoting the last message that had been sent and its store as a key value pair in peer of organization. Now, John has decided to send a new message to Kat and submit a request to the Node.js backend from the message dashboard. The Node.js SDK client takes this new proposed state and sends a proposal to all the endorsing peers of the organization as per the endorsing policy defined in the channel configuration, as well as confiding to the membership services. This includes a proposal request to invoke the corresponding function described in the chain code. The message thus gets verified by the orderer and finally gets committed to the CouchDB, thus confirming the transaction. Linux family. Hyperledger is a part of the umbrella project under Linux Foundation, where a community of developers work on open source projects. Linux Foundation provides infrastructure, services, events, training, and financial resources for creating sustainable open source ecosystems. Linux Foundation is known for its open source projects. Hyperledger is a consortium of organizations. It's not a blockchain platform. With Hyperledger, there are different blockchain projects. The original code for these projects was submitted by various companies like IBM, Intel, etc. Linux then made these codes open source to invite the entire community to work together and contribute to the codes. The vision was to create an enterprise-level blockchain platform. Hyperledger projects. Hyperledger umbrella strategy. Hyperledger nurtures a lot of blockchain frameworks and technologies under the umbrella strategy. Some of the well-known projects under Hyperledger are as follows. Sawtooth Lake. Hyperledger Sawtooth is a blockchain platform implementation which builds, deploys, and runs distributed ledgers. It is a modular platform which provides a digital record without a central authority or implementation. It is primarily used for supply chain networks. Fabric. Hyperledger Fabric's framework was contributed by IBM. Fabric works as a foundation for developing applications with a modular architecture. The framework utilizes container technology to host smart contracts, chain code, comprising the system's application logic. One of the examples where it is used is fishing industry to track the supply chain of fishes. Burrow. Hyperledger Burrow, hosted by the Linux Foundation, is a blockchain framework implementation. The framework was contributed by Monax and co-sponsored by Intel. Burrow is a permissioned smart contract application engine partially developed in accordance to the specifications of Ethereum Virtual Machine, EVM. It is used to run Ethereum smart contracts. Iroha. Hyperledger Iroha, hosted by the Linux Foundation, is another blockchain platform implementation. The framework was contributed by Soramitsu, Hitachi, NTT Data, and Kolu. Written in C++, Hyperledger Iroha incorporates a unique algorithm on chain-based Byzantine fault-tolerant consensus. It provides a small set of fast commands and queries covering most common operations for the digital asset and identity management. It can be used in mobile application organization. Indy. Hyperledger Indy is a distributed ledger and utility library built for decentralized identity. The distributed ledger provides tools, libraries, and reusable components to create and use independent digital identities based on blockchains. They are inoperable across administrative applications, domains, and any other silo. It is used as a decentralized identity database. Sawtooth. Hyperledger Sawtooth is a blockchain platform built for enterprise use where the design focuses on maintaining the safety of smart contracts and the ledgers are kept distributed. Sawtooth offers a simplified platform for blockchain application development by separating the application domain at the core system level. Application developers could opt for a language of their choice to write smart contracts logic. Following are some of the key features of Sawtooth: application layer in core system separation, parallel transaction execution, pluggable consensus algorithm, private networks with Sawtooth permissioning features, Ethereum contract compatible with Ceph, event system, Hyperledger Architecture, Hyperledger blockchain network participants. Following are the different participants within Hyperledger blockchain. Blockchain user. A blockchain user performs transaction on the network. The user can invoke a function from the chain code in order to send the instruction message to the underlying network, which can then process the transaction. Certificate authority. The certificate authority ensures that only certain restricted parties can be a part of the business network on Hyperledger. They access security certifications in order to determine the parties who have required privileges to be an actor on a network. Traditional database. It is a standard database which is used to store data. Traditional processing platform. It stores access to the logical code written, which is used to run the network as per the design. Blockchain development network. It operates the blockchain network, which enables the execution of smart contracts chain code, as well as various transactions that take place between the participants, which are part of the network. Blockchain developer. A developer develops applications on the blockchain using chain code. Currently, Hyperledger Fabric supports Node.js, Java, and Golang languages to write such chain codes. Regulator. Regulator runs oversight to ensure that the platform is operating without any bias. Hyperledger Architecture. Following are three main components of Hyperledger. Membership service. It is a set of cryptographic materials, certificates, that defines organization by itself. Every peer and orderer needs this type of certificate. This certificate has some common property by which we decide whether the peer and the orderer belongs to the same organization or not. A peer, which is a part of the same MSP, can communicate with each other. A peer from other organizations cannot be allowed to communicate with each other. Blockchain and transaction layer. This layer constitutes the core code of the blockchain. It comprises of consensus algorithm, which is required to make the final decision on the state of every transaction. It also contains the distributed ledger and ledger storage, which stores the entire history of the transactions and the last known states. Lastly, we have the P2P protocol, which is used for communication between different nodes on the network. Chain code. It is the logical programming layer which consists of the business logic required to run an operation on the Hyperledger. Permissioned blockchain and its consensus model. Permissioned blockchain maintains an access control layer and allows certain actions to be performed only by a few identifiable participants. It is also called private blockchain. Following are the properties specific to permissioned blockchains. It has legally accountable validators. It is suitable for off-chain assets. They can be used as an IT tool for settlement and clearing. Examples include Ripple, which determines roles for a select number of participants who can act as transaction validators on their network. Such blockchains are also popular among industry-level enterprises and businesses for which security, identity, and role definition are important. Permissioned versus permissionless blockchain. Let us see some differences between a permissioned and a permissionless blockchain. 1. In regards to access, a permissioned blockchain only allows pre-approved members to access the network and make transactions to it, whereas a permissionless blockchain allows anyone to be a part of the network as it is completely open and transparent. 2. Permissioned blockchain are faster than permissionless blockchain when it comes to performance, as they have less number of participants in the network. 3. Permissioned blockchain use different types of consensus algorithms like PBFT, proof of stake, and more. Usually, permissionless blockchains rely on proof of work. 4. The transaction cost in a permissioned blockchain is lower than that of a permissionless blockchain. 5. In regards to stability, permissioned blockchain are considered more stable compared to permissionless blockchains, as the former have a better governance due to known parties which are a part of the network. 6. In a permissionless blockchain, all participants have the same level of access, whereas a permissioned blockchain provides full access only to the members which are registered to be a part of the business network. 7. Permissionless blockchains work in a peer-to-peer fashion, relying solely on consensus algorithms to create a trusted environment. However, permissioned blockchains have trusted members as part of the network, which enhances the trust on the network. Consensus and its interaction with architectural layers. Consensus. Consensus is the process by which a network of nodes validates the block of transactions and provide a guaranteed ordering of transactions and validating those block of transactions that need to be committed to the ledger. Consensus must ensure the following in the network. Confirms the correctness of all transactions in a proposed block according to endorsement and consensus policies. Agrees on order and correctness and hence on the results of execution. Depends on smart contract layer to verify correctness of an ordered set of transactions in a block. Hyperledger makes use of the permissioned voting-based consensus from the pool of the other consensus named the lottery-based consensus. Consensus properties. Consensus must satisfy two properties to guarantee agreement among nodes: safety and liveness. Safety means that each node is guaranteed the same sequence of inputs and results in the same output on each node. The algorithm must behave identical to a single node system that executes each transaction atomically one at a time. Liveness means that each non-faulty node will eventually receive every submitted transaction, assuming that communication does not fail. Activities performed to reach consensus. Hyperledger frameworks reach consensus by performing two activities: transaction ordering, transaction validation. By logically separating these activities, we ensure that any Hyperledger framework can work with any Hyperledger consensus module. The first step of the consensus process flow is receiving the transactions from the client application. Consensus depends on an ordering service to order transactions. Transaction order enables confidentiality of the transactions. It also increases the efficiency of the transactions. To validate transactions, Consensus depends on the smart contract layer because it contains the business logic behind what makes a transaction valid. Transaction validation contains business logic to make the transaction valid. It also ensures the confirmation of policies and contracts specified for the transaction. Then, it also checks for syntax and logic errors. Consensus model for permissioned blockchain. Consensus in Hyperledger Fabric, as seen in the image above, is broken out into 3 phases: endorsement, ordering, and validation. Endorsement is driven by policy, e.g., M out of N signatures, upon which participants endorse a transaction. Ordering phase accepts the endorsed transactions and agrees to the order to be committed on the ledger. Validation takes a block of ordered transactions and validates the correctness of the results, including checking endorsement policy and double spending. As soon as a new transaction is created, it is sent to the endorsement peer to generate a read-write pair. The read-write pair from every endorser is then sent to the orderer, which orders the same and generates a block based on consensus. The ordered block is then sent to the validator to update the couch DB with the most recent state. API and network topology in Hyperledger. API. It enables clients and applications to interface to the blockchains. Hyperledger supports the following types of APIs. Admin APIs. This class creates an administration connection to a Hyperledger Composer runtime. The connection can then be used to deploy business network definitions, undeploy business network definitions, update business network definitions, send a ping message to the runtime to ensure it is running and correctly configured, store a connection profile document in the connection profile store. Common APIs. They are used to obtain information about the connected networks. This information can include business network, metadata, enum declaration, and many more. Runtime APIs. These are used to perform all transaction operations like running a query, managing assets, and more. Network topology. Network topology is a technical infrastructure that provides smart contract services and ledger to applications. Listed below are the components of network topology. Ledger. A ledger consists of 2 distinct parts, a blockchain and the state database. Unlike other ledgers, blockchains are immutable. In contrast, the world state is a database containing the current value of the set of key value pairs that have been added, modified, or deleted by the set of validated and committed transactions in the blockchain. Smart contract. A smart contract is a code that is invoked by a client application external to the blockchain network. It manages access and modifications to a set of key value pairs in the world state. In Hyperledger Fabric, smart contracts are referred to as a chain code. Peer nodes. It is a network entity that maintains a ledger and runs chain code containers in order to perform read-write operations to the ledger. Peers are owned and maintained by members. Ordering service. It is a defined collective of nodes that orders transactions into a block. The ordering service exists independent of the peer processes and orders transactions on a first-come, first-served basis for all channels on the network. Channels. A channel is a private blockchain overlay which allows for data isolation and confidentiality. A channel-specific ledger is shared across the peers in the channel, and transacting parties must be properly authenticated to a channel in order to interact with it. Fabric certificate authorities. Hyperledger Fabric CA is the default certificate authority component which issues PKI-based certificates to network member organizations and their users. The CA issues 1 root certificate to each member and 1 enrollment certificate to each authorized user. Steps to create a Hyperledger network. Following steps should be followed to create a Hyperledger network. Step 1. Create a network. The network is created from the definition of the consortium, including its clients, peers, channels, and ordering service. The ordering service is the administration point for the network because it contains the configuration for the channel within the network. Step 2. Define a consortium. A consortium is comprised of 2 or more organizations on the network. Consortiums are defined by organizations that have a need for transacting business with one another, and they must agree to the policies that govern the network. Step 3. Create a channel for consortium. A channel is a means of communication used to connect the components of the network and/or the member client applications. Step 4. Join peers to channels. Peers are joined to channels by the organizations that own them, and there can be multiple peer nodes on channels within the network. Step 5. Install smart contracts. Smart contract chain code must be installed and instantiated on a peer in order for a client application to be able to invoke the smart contract. Step 6. Optimize the network. While there is no theoretical limit on how big a network can get, as the network grows, it is important to consider design choices that will help optimize network throughput, stability, and resilience. Step 7. Add another consortium definition. As consortia are defined and is added to the existing channel, we must update the channel configuration by sending a channel configuration update transaction to the ordering service. Step 8. Add a new channel. Organizations are what form and join channels, and channel configurations can be amended to add organizations as the network grows. When adding a new channel to the network, channel policies remain separate from other channels configured on the same network. Step 9. Add peer and join it to multiple channels. You can continue adding new peers and connect them to several channels within the network. Network topology. The diagram above shows a fabric network with the following configuration. There is a fabric network N with network policy NP1 and ordering service O. Channel C1 is governed by channel policy CP1. Channel C1 has been established by consortium RARB. Channel C1 is managed by ordering service O and peers P1 and P2, and client applications A1 and A2 have been granted permission to transact on C1. Client application A1 is owned by organization RA. Certificate authority CA1 serves organization RA. Peer P2 maintains ledger L1 associated with channel C1 and L2 associated with C2. Peer P2 makes use of chain code S4 and S5. The orderer nodes of ordering service O are owned by organization RD.
Meet Frank and Daniel. One day they decide to go for a trip to Venice. They made a budget list for all their expenses like residence, flight, etc. They thought of making their bookings online from a site that offered discounts to the first 10 visitors on that day. While making their respective flight bookings, Daniel's transaction failed, and he missed the offer going on. On the other hand, Frank paid his share very quickly and easily, and became one of the 3 lucky draw winners. Daniel was surprised and asked Frank how he could make the transaction when Daniel himself could not. To which his response was, "It's simple. I used Bitcoin, a type of cryptocurrency." Daniel was confused, and he asked what cryptocurrency is, and since when has it been in use? Frank stepped up and explained to him. Cryptocurrency is a virtual or digital currency that works on blockchain technology and is designed to work as a medium of exchange online to buy goods and services and make payments, which was introduced to the world first in 2013 by Satoshi Nakamoto. Daniel felt that it sounds similar to other online payment options. He asked what makes it so different. Frank explained, cryptocurrency is decentralized and free from any third-party interference, which means it is not issued and controlled by any government or central authority, unlike other payment systems that banks or governments are handling. And that's why a cryptocurrency transaction never fails. There could be many reasons for why Daniel's transaction failed, like he may have exceeded his transfer limit, or his account must have been hacked, or there could have been some technical issue with his bank server, or maybe due to high transaction fees imposed by the bank. But on the other hand, cryptocurrency charges almost no or very low transaction cost. There is no limit for making transactions. In fact, you have 24/7 access to your money. There is no extra delay or extra charges on making international transactions. And the best part is that anybody can use cryptocurrency without the hassles of paperwork. All you need to do is create an account on any digital wallet of cryptocurrency. This is what makes cryptocurrency different from other online payment options. Daniel was impressed by cryptocurrency, but he wondered how it works without the control of an external authority. Upon research, he found out that cryptocurrency works on blockchain technology. Blockchain is a set of blocks that record information of transactions, like who made the transaction to whom, the amount of trade in the form of a digital ledger that is distributed across the entire network, meaning the data is replicated and stored on each node across the entire blockchain network, making it more secure and impossible to change, hack, or cheat the system. Then it is verified and validated by every node to proceed with the process of making the transactions. The crypto in cryptocurrency stands for cryptography, which is a method of using encryption and decryption to secure the data in the presence of any third party with ulterior motives. Now Daniel was completely aware of the whole technology and concept behind cryptocurrency, and was influenced by Frank to adopt cryptocurrency in his daily lifestyle too. He did that by booking his ticket, but sadly, no discount. Like Daniel, cryptocurrency has influenced and impacted an enormous number of people worldwide. Due to this increasing popularity, new companies like Meitu and PayPal are coming forward and investing in cryptocurrency every day. In 2018, Malta, an island located in the Mediterranean Sea, south of Italy, was titled Blockchain Island, as it led to the economic stability of the nation. Many fintech companies like Binance and OKX have already begun to take advantage of Malta's financial incentives and have moved their headquarters to the blockchain island. So, here is a question for you. Which hashing algorithm does cryptocurrency use? A. Script. B. Ethash. C. SHA-256. D. None of the above. Please give it a thought and drop your answers in the comments section below. Cryptocurrency is revolutionizing finance and banking around the world. Thanks to cryptocurrency, now anyone with an internet connection can trade, spend, and borrow money around the world, and nobody can stop them. People like Bill Gates, co-founder of Microsoft Corporation, and Elon Musk, CEO of Tesla, support cryptocurrency, as it is much better and secure than physical money and also holds a great future for the world's economy. And on the other hand, some people think of cryptocurrency as a bane to the world's economy, like Warren Buffett, CEO of Berkshire Hathaway, and Ajay Banga, CEO of Global MasterCard, feel that cryptocurrency is a platform of criminal activities and will destroy the world's economy. Well, one thing is clear, that this conflict is going to stay put for a little longer.
Welcome to this session of Blockchain Wallet. Now, before these blockchain wallets came into existence, what were the means in order for us to do the transactions, and what were the drawbacks? In the old days, the transactions with whatever medium and channels we had, the problems were that the transactions were slow and banks were the central point of failure. Basically, any transaction which has to go through some intermediary channels and has to pass through certain intermediaries like bank, which makes them a single point of failure. Also, there are issues in keeping track of all accounts and balances. Data get jeopardized, manipulated, or even get corrupted across multiple systems where the accounts and balances are maintained. Now here comes into existence what is called as blockchain wallet. Now what is blockchain wallet? A blockchain wallet is a cryptocurrency wallet that allows users to manage different kind of cryptocurrencies, for example, Bitcoin, Ethereum, etc. Now, a blockchain wallet helps exchanging of funds easily. Transactions are secure as they are cryptographically signed. The wallet is accessible from web or mobile devices, and the privacy and identity of the user is maintained. So therefore, a blockchain wallet provides all the features which are necessary for a safe and secure transfer and exchange of funds between different parties. A blockchain wallet is a typical cryptocurrency wallet that allows users to manage cryptocurrencies. It is very similar to the process of sending or receiving money through PayPal or any other gateway which you use today. But now you can use cryptocurrency instead, similar to PayPal, which you're using for making transactions with your fiat currency. Now let's take a look at the ecosystem of blockchain wallets. Here are certain examples like Electrum, blockchain.info, Jax, Mycelium, Samurai, and Bitcoin Paper Wallet. These are just to name a few blockchain wallets which are existing in the market, but there are many more based on the requirement you have, based on the security you require, and based on the kind of wallet which suffices your need. So we will see what are the categorizations of these kind of wallets are. Now, how do blockchain wallets work? Let's take a look. So before we move on to how blockchain wallets work, let's understand what a private and a public key is and how are these keys related to a blockchain wallet. Now, whenever you create a blockchain wallet, you are also provided a private and a public key which is associated with your wallet. Now, let's take an example in order to understand this. Imagine a person knowing your email address is sending you an email. So in our regular day-to-day activity, if we want to receive an email from someone, we give him or her our email ID and expect an email from them. Now, what if an unknown person is able to send emails through my account? So I am giving my email address for receiving emails, but when I am disclosing my email ID, I'm not assuming that someone will be able to send emails through my account, because then for that he has to be aware of my email account password. So knowing your email address will not give a person the ability to send an email from your account. You are not giving your password to the person to send an email. You're just giving the email address. To send an email from a particular email address, an individual has to be aware of the password associated with it. Now, blockchain wallet follows a similar process using public key and private key both together. Public key is similar to your email address. So basically, whenever your wallet is generated, a public key is generated, you can share that public key with anyone in order to receive funds. Private key is top secret. It's similar to your password. It should not get hacked or you should not disclose it to anyone. And you use this private key to spend your funds. Now, instead of sending an email, imagine you want to transfer money to your friend. This transfer process is done through your blockchain wallet. With blockchain wallets, you can now send and receive cryptocurrencies. So as I said, a blockchain wallet has two keys, a public key and a private key. Public key is shared with everyone, just like an email address. Private key is just like your password, which should be kept secret with the sender. So with blockchain wallet, no one will be able to send crypto coins just like emails through your public key until they know your private key. But if someone gets access to your private key, there is a high possibility that your account is hacked and you might end up losing all the cryptocurrency deposits in your account. Now let's take a look. What are the typical features of a blockchain wallet? It's easy to use. It's just like any other software or a wallet which you use for your day-to-day transactions. It is highly secure. It is just like a matter of you securing your private key, and it allows instant transactions across geographies, barrier-free, without intermediaries, and also these transactions charges you low-cost fee. And these wallets help you do transactions across multiple cryptocurrencies. So you can make payments across cryptocurrencies, which helps you do easy currency conversions. Now let's talk about what are the different types of blockchain wallets. Now basically there are two types of blockchain wallets based on the private keys. One is hot wallet and another is the cold wallet. Hot wallets are like normal wallets which we carry for day-to-day transactions, and these wallets are user-friendly. Cold wallets. Cold wallets are similar to a vault where cryptocurrencies are stored with a high level of security. Now let's take a look at the differences. Hot wallets are online wallets through which cryptocurrencies can be transferred quickly. They are available online on internet. Example, Coinbase, blockchain.info. Cold wallets, they are digital offline wallets where the transactions are signed offline and then later disclosed online. So they are not maintained on the cloud on the internet. They are maintained offline to have high security. And the examples of cold wallet are Trezor and Ledger. Now, in case of hot wallets, private keys are stored in the cloud for faster transfer. In case of cold wallets, private keys are stored in a separate hardware which are disconnected from the internet or the cloud or are stored in a paper-based document. Hot wallets, they are easy to access, available online 24/7. It can be accessed through desktop or mobile, but has a risk of unrecoverable theft when hacked. Cold wallet, this method of transaction helps in protecting the wallet from unauthorized access, from hacking and other online vulnerabilities. Now, the wallet can be further distinguished on these criteria. There can be software wallets, there can be hardware wallets, which are like kind of USB driven and you plug into your USB drive and your hardware wallet can be used, or they are a typical paper-based wallet where you print your public key and a private key on a paper and keep it in a secure place. So let's talk about software wallet. A software wallet is an application that is downloaded on a device. Either it could be a desktop or a mobile, or it could be a web-based wallet which can be accessed online. Now, here are certain examples. Zax, Bread Wallet, and Copay are the popular software wallets. So software wallet can be further categorized into desktop wallet, online, or we can call it web wallets or mobile wallets. Now desktop wallets are like cold wallets in which the private keys are stored in cold servers. Basically, the desktop wallets, the private keys are stored in your desktop. You can unplug it from the internet, do some offline transactions, and then bring it back online. Now, in case the main server is lost, then a cold server, basically your desktop, is used as a backup server. These wallets can be downloaded on any computer, but can only be accessed from the system they are installed on. So you make sure the desktop or the machine on which you have downloaded the desktop wallet is safe, has a backup, you're maintaining the hardware, you're not letting the machine go anywhere, and it is on a secure location. Now, these wallets are definitely cost efficient, and one of the examples is Electrum and is one of the most popular desktop wallets. Online wallets are the other kind of hot wallets that run on the cloud, that are available on the internet. Now here users have the benefit of accessing these wallets across any device. It could be tablet, desktop, or you can use it from your mobile browser. The private keys are stored online and are managed by a third party. You have to be dependent on a third party service. Now, for example, Green Address is a Bitcoin wallet which is available on the web, has an Android app, is available on a desktop, and also is available on iOS, Apple. Mobile wallets. Mobile wallets are like similar to online wallets, except that they are built only for mobile phone usage and accessibility. These wallets are also user-friendly and they have a user-friendly interface which helps you in doing transactions easily. The example is Mycelium, which is the best available mobile wallet. Hardware wallets. Hardware wallet is a type of a cold storage device, typically like a USB, which stores the user's private key in a protected hardware device. These wallets are similar to portable devices that can be connected to the computer, can be plugged in. As I said earlier, it is less prone to malware attacks, malicious attacks, and it is hack proof. Examples are NanoLedger, Trezor, and KeyKey are the top hardware wallets available in the market. To make a transaction from your hardware wallet, you have to ensure the hardware wallet is plugged into your computer system before you can do a transaction from your hardware wallet. Paper wallet. A paper wallet is an offline process for storing cryptocurrencies. This wallet is a printed paper consisting of both your private key and a public key, which are accessed using a QR code. Now, since these wallets are safe, they are widely used for storing large amounts of cryptocurrencies. Now, examples are Bitcoin paper wallet and My Ether wallet are one of the widely used paper wallets. But the question arises, how do I add cryptocurrency in my paper wallet? In order to make a transaction with your paper wallet works with your software wallets, the online wallets, to transfer funds from your software wallet to the public address shown on your paper wallet. So basically, first you park your funds in a software wallet, then you transfer the funds from your software wallet to the public address printed on your paper wallet. Now let's do the comparison. Blockchain Info. Blockchain Info is a cryptocurrency wallet which supports Bitcoin and Ethereum. It is easy to use and has a low transaction fee. It has its APIs exposed. You can easily use them in order to make your own custom wallets also. Ledger Nano. Ledger Nano is a hardware wallet which offers a high security to your account. It is available for Bitcoin, Ethereum, and Litecoin users. It is also possible to maintain multiple accounts and access them anytime. Bitcoin Paper Wallet. Paper Wallet helps you to print your own tamper-resistant Bitcoin wallet. It minimizes the threat of hacking. Jax is a software wallet which enables a user to exchange currencies within the wallet. It is available for Bitcoin, Ethereum, Litecoin, and many other cryptocurrencies. With Jax, a user can view his updated balance as soon as the processing is complete. Now let's take a look at certain demos for the different kind of wallets we have talked about. So let's first take an example of paper wallet. So bitaddress.org provides you a paper wallet. It uses the client-side JavaScript in order to generate a random hash for your wallet. So you keep moving your mouse and it will generate a hash, public and private key. It is recommended that when you are doing this process, you should be disconnected from the internet, and once these keys are generated, you can print it and keep it secure and clear the cache of your browser. So as you can see on the screen, this is my public key for receiving my Bitcoins, and this is the private key for me to spend it. I can print it and keep it handy with me. But of course, the safety of these physical documents cannot be entirely guaranteed. If a hacker discovers the location of your paper wallet and physically steals it, then they can access your Bitcoin holdings. So basically, it is of high importance that you keep the paper wallet in a very, very secure location. Some users hide or disguise the paper wallet. It should be protected from physical damage. If the keys fade or can no longer be scanned, then the user will never again be able to access the Bitcoin which are parked in that address. Also take care if you are using an incorrect type of printer, that also may damage the paper wallet. Now let's take a look for our second example of online wallet. Here we are taking an example of BitPay. So you can download BitPay online and create your account over here. You can create a personal wallet, you can create a shared wallet or a joint share wallet. Once you create a wallet, like if you see the example over here, this is my personal wallet and I have 3.645 test Bitcoins over here. Now, in order to receive test Bitcoins in my account, you can receive these test Bitcoins from testnet.coinfaucet.eu-in. Now, in order to receive it, you just need to copy your Bitcoin address in the testnet address. So the testnet has given me 0.87 Bitcoin. So now my balance has increased from 3.5 to 3.64 and I can see this transaction. See, 3 minutes ago, I just received 0.872287 Bitcoin. The transaction is still in process, but in a while, as this transaction is getting mined on the testnet, I will receive it. Now, as I have received it, I can even make a transaction and send it to someone. So from my personal account, I can send Bitcoin to someone whose Bitcoin address I have, and I have to just paste it over here. Transfer to Bitcoin wallet. Either I can select one of my own wallets, or I can search for any other Bitcoin address which someone has shared with me, and I can send it to that particular address. Now let's take an example of our hardware wallet. How does hardware wallet works with the online wallets? So here we have MetaMask, which has a feature of connecting with hardware wallet. So once you have MetaMask installed, you will see this option of connect hardware wallet. Now MetaMask has provided support for Trezor. So now once you connect your hardware wallet, the USB with your computer, you can select an account you want to view on that particular hardware wallet, and you can only choose one at a time, and then you can start using that particular wallet for your decentralized apps. So basically, once you have your hardware connected, it is integrated with your MetaMask, and then you can start running your decentralized apps so that they can start using the tokens or the currency in the particular hardware wallet. So use your hardware account like you would with any Ethereum account, log into dApps and send Ethereum's buy and store ERC20 tokens and non-fungible tokens like Cryptocurrencies. So if you click connect to Trezor over here, MetaMask will start looking out for the connected Trezor device. Now what is Bitcoin? Bitcoin is the first decentralized digital currency that allows users to transfer money peer-to-peer without any intermediaries like banks, governments, agents, brokers. Nothing is involved, and all this is done using blockchain technology. So as we saw in our previous example, two parties wants to exchange money, transfer money, they don't need an intermediary. Now Bitcoin can be used for online purchases, e-commerce transactions. It can be used as an investment instrument, and it can be primarily used for payments to buy goods and services. Now, it was created in 2009. It came into existence by a person or a group of people called Satoshi Nakamoto. Now, Bitcoin helps transferring of assets faster than regular fiat currencies. It has definitely lower transaction fees because as it has removed the intermediaries from between, the cost of transaction also goes down, and it is cryptographically secure. It uses cryptography infrastructure, and thereby the identities of the sender and the receiver are also secure, and the entire transaction is cryptographically signed. And the users' information who are doing the transactions or are part of the network is also hidden and secure. Now, what are the advantages of Bitcoin? So it allows fast and quick peer-to-peer transactions. It is impossible to counterfeit or hack the transactions which are running on a Bitcoin network. And it's an overall decentralized process. There is no centralized body which is controlling the transactions or charging a fees in order to validate the transaction. It is the participants in the decentralized network who are taking care of the sanity of the network, thereby making sure that the overall transaction cost is low. All the information is accessible to public. It is available publicly on a public ledger. Anyone can go and view the transactions and the volume of the transactions happening on the Bitcoin network. And it is a low fee transaction. It is comparatively low to other mediums and channels through which today digital transactions are made. Now, what is blockchain? So Bitcoin runs on the underlying technology of blockchain. Blockchain is a public distributed ledger in which transactions made in Bitcoins or any other digital currency are recorded in a chronological order. So let's see certain features. It is cryptographically secure, signed using your private key and then shared on the network with the public key. It is immutable. Any record or any transaction added on the blockchain cannot be modified or altered. It is run by a decentralized system. There is no centralized authority or the body, and the transactions are stored in containers, aggregated in containers called blocks. So a block is the smallest unit of a blockchain which records all the transaction. A basic structure of a block is something like this. It has 4 fields. These are the primary attributes of a block. It has something called as previous hash. So the previous hash attribute stores the value of the hash of the previous block, and that's how the blocks are linked to each other. Data, this is the aggregated set of transactions which are included in this block. So these are the set of transactions which were mined and validated and included in the block. Nonce. So in proof of work consensus algorithm, which is used in Bitcoin, nonce is a random value which is used to vary the output of the hash value. So every block is supposed to generate a hash value, and nonce is the parameter which is used to generate that hash value. And the proof of work is the process of transaction verification done in blockchain. Now hash is the resultant hash value obtained by passing the previous hash value, the data and the nonce through the SHA-256 algorithm to generate the hash of this block. So this is the digital signature of the block which is generated, and this is the basically identity of this block. Now SHA-256 is a cryptographic hash algorithm which produces a unique 256-bit alphanumeric hash value for any given input, and that is the unique feature of this cryptographic algorithm. Whatever input you give, it will always produce a 256-bit hash. Now let's understand the concepts of Bitcoin mining. What is Bitcoin mining? Bitcoin mining is the process of verifying Bitcoin transactions and recording them onto the public blockchain ledger. In blockchain, the transactions are verified by Bitcoin users. So basically, the transactions have to be verified by none other than the participants of the network, those who have the required hardware and computing power, and those entities are called miners, so we will be talking about them later. But the point to be highlighted is that there is nothing like a centralized body as in case of legacy transactions where we used to be dependent on a regulatory or governing body or a bank to make our transactions go through. Now in Bitcoin, here any user with mining hardware and internet access can take a part. That kind of computer can be a participant and contribute to the mining community. Process is solved based on a difficult mathematical puzzle called proof of work. So every miner's job is to solve the mathematical puzzle which is called proof of work in order to validate the transaction and earn the reward. And all the miners, as they are competing amongst themselves to mine a particular transaction, the miner who first solves the puzzle gets the reward. Now users trying to solve the puzzle, as I said, are called miners. They are the participants in the network who have the necessary hardware and computing power to do all the transactions, to validate the transactions and validate it. They are called as miners. Now in order to understand Bitcoin mining, we need to understand three major concepts of blockchain. It is based on distributed public ledger. It uses SHA-256 encryption algorithm, and proof of work is the underlying consensus algorithm for Bitcoin mining. So distributed public ledger. A distributed ledger is a record of all transactions maintained in the blockchain network across the globe. In the network, the validations of transaction is done by Bitcoin users called as miners, SHA-256. Now, blockchain prevents unauthorized access by using a hash function called SHA-256 to ensure that the blocks are kept secure. They are digitally signed. Their hash value once generated cannot be altered. Now, SHA-256, it takes an input string of any size and returns a fixed length 256-bit output value, and that is the primary feature of SHA-256 encryption algorithm. You give any input, it will always give you a 256-bit output, and it is a one-way function. You cannot derive the input reversely from the output what you have generated. And third is the proof of work. In blockchain, mining is a process to validate transactions by solving a difficult mathematical puzzle called proof of work. Now, in order to do that, the primary objective of the miner is to determine the nonce value, and that nonce value is that mathematical puzzle that miners require to solve in order to generate a hash which is less than the target defined by the network for a particular block. Now, in the Bitcoin network, users trying to solve mathematical puzzle are called as miners. Now, the puzzle is solved by varying a nonce which produces a hash value lower than a predefined condition which is called as the target. Miners verify the transactions and add the block to the blockchain when confirmed and verified. As of today, the miners who solve the puzzle gets a reward of 12.5 bitcoins. Now, once a block is added to the blockchain, the bitcoins associated with the transactions can be spent. So once the block is validated, then the transfer of bitcoins associated with the transactions aggregated in the block, the transfers are made then from one account to the another. Now, in order to generate the hash, let's see, you use the SHA-256 hashing algorithm. You define the hash value. If it is less than the defined condition, the target, then the puzzle is deemed to be solved. And if not, then you keep on incrementing nonce value and you repeat the SHA-256 hashing function, passing on to the nonce value, and you generate the hash value again, and you keep doing this process till the time you get the hash value which is less than the target. Now let's take an example. So for example, Beyonce wants to share 10 Bitcoin with Jennifer. Now in order to do that, what will be the steps? So Beyonce's transaction data is shared with Bitcoin users, the miners, from the memory pool. The transaction goes and sits in a memory pool of unmined transactions. So in a memory pool, set of unmined or unconfirmed transactions wait until they are verified and included in a new block. They remain in that unconfirmed transaction pool. Now, miners competing to validate the transaction using proof of work, they keep on continuously polling the unconfirmed transaction pool. They pick up those transactions and start validating those transactions. They aggregate in a data block and start validating. They start solving the puzzle. The miner who solves the puzzle first shares his result across the other nodes, the other set of miners. Now, once the block is being verified, the nonce has been generated, then the nodes will start granting their approval. If maximum nodes grant their approval, the block becomes valid and is added to the blockchain. Now simultaneously, the miner who has solved the puzzle will also receive the reward in the meanwhile, which will be of 12.5 Bitcoin, which as of today stands at 98k around dollars. Now the bitcoins, the 10 BTC for which the transaction was initiated, now will get triggered and will get transferred from Beyonce to Jennifer. Now let's take a look at certain facts. In proof of work, a predefined condition, the target, is adjusted for every 2016 block, which is approximately every 14 days. And an average time to mine a block is 10 minutes. So basically, the target keeps automatically adjusting itself to keep the block generation within the 10-minute time frame. So this is the representation. So in order to keep the time frame for block generation within 10 minutes, the target keeps on adjusting itself. Now, the difficulty of the puzzle changes, the target changes depending on the time it takes to mine a block. So this is how a difficulty of a block is being generated. It is the hash target of the first block divided by the hash target of the current block. So this is the difficulty which is being changed after every 2016 blocks. So basically, it is very hard to generate the proof of work, but it is very easy to verify by the miners. So once you have solved the puzzle and you have broadcasted that yes, you have earned, you have validated a record, you have determined the puzzle, for other miners it is very easy to verify what you have done. And once they give their consensus, the majority, then the block gets validated and gets added to the blockchain. Now, since the difficulty depends on the hash target, its value keep on changing after every 2016 block, as I said. And as you can see, in due course, from the day of inception of Bitcoin in 2009 till today, difficulty has increased exponentially and it has been increasing, and thereby the entire effort of mining and the computing power is also increasing. So as of what was the resources which were required to do mining in 2009, you require more hashing power, more computing power in order to do the mining today. Now, what if someone tries to hack the data? So let's see. Blockchain is a chain of blocks, ABC. Now, each block has solved a puzzle and generated a hash value of its own, which is its identifier. Now, suppose a person tries to tamper a block, the block B, and tries to change the data, which is aggregated in the block. So if the data of the block will change, the hash value, which is the digital signature of the block, will also change. Thereby, it will corrupt the chain which is subsequent to it, basically the blocks ahead of block B will all get delinked because the previous hash value of block C will not remain valid. So in order for the hacker to make the entire blockchain valid for the block B which he has changed, he has to change the hash value of all the blocks ahead of block B, which will require huge amount of computing power, which will be next to impossible. So as you see, the results in the following block being invalid. So with this whole thing, the blockchain is making sure that the entire sequence remains non-hackable and prevent data modification. Now let's see what are the underlying hardware requirements for Bitcoin mining and how the hardware has evolved. So in the early days, miners used to solve the puzzles using regular processors, the controlling processor unit CPUs. Now, but it used to take a lot of time for mining, though the difficulty levels were low, but still it used to take a lot of time. Now, as I said, the difficulties level keep on changing and growing. So the miners also had to increase the processing power. So they discovered that graphical processing units, GPUs, proved to be more efficient than regular CPUs. So, but this also had a drawback of consumption of electricity. So any miner who has to calculate the return on investment on the hardware, he also has to accommodate the cost of electricity and other resources which are going in order to do the mining. So finally, as of today, they are using a hardware called ASIC, Application Specific Integrated Circuit, which was specifically introduced for mining, which consumes less power and has a higher computing power and a better hardware for mining. So miners are profitable when their cost of resources to mine one block is less than the price of the reward they receive. So definitely they have to have the investment less than the reward what they earn. So as of today in blockchain, miners use their resources to verify a transaction. Each time a block is mined, new bitcoins are created in the network. So the Bitcoin total supply is limited. It is at $21 million. Approximately 21 million Bitcoin are in supply. 17 to 18 million Bitcoins have already been mined. So only 3 to 4 million are left. As of today, a reward of 12.5 Bitcoin is given to the miner on doing the transaction verification, but the Bitcoin mining reward goes by the halving principle. The reward given to a miner is halved every 210,000 blocks, which is approximately every 4 years. So then after that threshold is reached, the Bitcoin reward will go down to 6.25 Bitcoins. So let's take an example of a lottery ticket where your chances of winning is difficult. So we are talking about what is Bitcoin mining pool. Your chances of winning the lottery is difficult, but in a community, if individuals buy multiple lottery tickets and pool their tickets together, then this will increase their probability and chances of winning more. So suppose you won the lottery, then based on the contribution, the reward is distributed amongst all the participants. Bitcoin mining pool is a similar thing. It's a process where multiple nodes share their resources together to mine a block. Now when a block is solved, the miners split the reward equally based on the amount of processing power they have invested. So it takes the pool members to generate a final hash value. Then it checks how much amount of work was contributed by each pool member. And as a result, the Bitcoin reward gets distributed proportionally amongst the participants. Now let's take a look at a demo on how can you see what is the Bitcoin reward. Now this is an actual block of the Bitcoin network. As you can see, this is a block and this is the block reward, 12.5 Bitcoin. So this was a block which was mined. This is the block number and these are the set of transactions which were part of this block. Now once this block was mined by the miner, all these transactions then be done. These are the transfers of Bitcoin from one account to the other. This is the nonce which was generated by the miner or the mining pool in order to mine the block. And these are the other attributes. And if you take a look at this URL, this is an example of a mining pool. It's a demo account where the participants have shared their mining resources and they are mining it in a pool. And see, this is the reward for which they are mining. This is the unconfirmed reward. This is the confirmed reward. This is what they have already validated and this is what they have earned so far. So these are the hash, these are the block numbers which they have mined.
Ethereum and its concepts. Ethereum. Simply put, While Bitcoin is defined as digital money, Ethereum is a decentralized platform that runs the smart contracts exactly the way they are programmed, without any downtime, fraud, and third-party interference, and also has its own cryptocurrency called Ether. Ethereum aims to enable innovations in 3 key areas: currency assurance through Ether, which serves as an innate currency for the Ethereum blockchain; decentralized autonomous organization; smart contracts. Features of Ethereum. The first feature of Ethereum is that it is secure because it is almost impossible to tamper with the transactions in the block or to add any fraudulent blocks in the network. The second feature of Ethereum is its community following. Ethereum has attracted a lot of attention from people all over the world. The third feature of Ethereum is its corporate-friendly structure. The platform is being leveraged by a number of corporates to test and build various applications. The fourth feature that we will take a look at is the possibility of creating new assets on Ethereum blockchain that can be used as currency, a representation of an asset, a virtual share, a proof of membership, or anything at all. The next feature is the ability of Ethereum to process the transactions fast. While Bitcoin requires a block time of 10 minutes, in Ethereum, it's only a few seconds. The last feature that we will discuss is the fact that Ethereum is uncensored. Ethereum's open source network allows complete transparency to view every transaction. All right, that's all about the features of Ethereum. Let me tell you about an important concept in Ethereum called gas. Gas in Ethereum. Gas is the fundamental block of Ethereum ecosystem that is paid for every operation performed on the Ethereum blockchain. It is the crypto fuel for Ethereum. It can be considered a transaction fee which has to be paid when one party sends ethers to another party. Even when a person deploys a smart contract on the Ethereum blockchain, a transaction fee needs to be paid for that as well. This payment has to be made regardless of whether the transaction succeeds or fails. Gas price is expressed in Ether, and the miner decides whether to refuse the transaction process or not based on the expected gas price. One can see their transaction fee in ETH or USD when searching for the transaction on etherscan.io. When somebody refers to gas, they are either talking about gas price or gas limit. The total cost of a transaction is the product of gas limit and gas price. The gas limit is defined as a limit since it's the maximum amount of units of gas one is willing to spend on a single transaction. This avoids situations where there is an error somewhere in the contract and you end up spending a very high amount of gas. However, the units of gas required for a transaction are defined by the amount of code executed on the blockchain. Lowering the gas limit below the amount required will not help much. If enough gas to cover the computational resources of the network is not supplied with the transaction will fail due to an out-of-gas error. So, gas is a commodity which is essentially a cost of using the system. Like Bitcoins, Ethereum also has its currency, which is called Ether. Ether. It is an incentive that the client of the platform pays to execute requested operations. It ensures that the developers write error-free codes because unnecessary codes will increase the cost. Ethereum is a blockchain-based platform, and Ether is the cryptocurrency that fuels the platform. It is commonly denoted as ETH. Let's have a look at the differences between Bitcoin and Ether. Bitcoin versus Ether. The first difference is in the hashtag algorithm used by these cryptocurrencies. While Bitcoin uses SHA-256 to encrypt blocks of blockchain, Ethereum uses Ethash to encrypt blocks. Technically, Both are one-way cryptographic hash functions. The second difference is in the use of Bitcoin and Ether. As we have discussed earlier, Bitcoin is only used for financial transactions like purchase and sale of goods and services. However, Ethereum, being a Turing-complete platform, also supports smart contracts and decentralized applications. The third difference is in the price of the two cryptocurrencies. Currently, the price of BTC is approximately $3,500 while that of ETH is approximately $100. The market cap of BTC is almost 6 times greater than that of BTC, even though ETH has a higher circulating supply. The fourth difference is in the vision behind creation of these two cryptocurrencies. BTC is a currency created to compete against the gold and fiat currencies by acting as an alternative. However, ETH is created as a token to facilitate smart contract deployment and operations. Lastly, the transaction speed of BTC is much slower than ETH. While BTC's transaction speed is measured in minutes, ETH is just a few seconds. Like Bitcoins, Ethers are also stored in cryptocurrency wallets. Let's understand what are wallets in Ethereum. Ethereum Virtual Machine, Ethereum Wallets. A wallet is the place to securely store ethers and other cryptocurrencies. Basically, a wallet stores the means of accessing your currency using the private key. Now that I have told you about the Ethereum and its currency, it will only be fair that I explain EVM now. EVM. Ethereum Virtual Machine, abbreviated as EVM, is an engine which executes translation code. Smart contracts are compiled into bytecode, which an EVM can read and execute. The Ethereum Virtual Machine can be regarded as a quasi-Turing complete machine. It possesses its own programming language, known as the EVM bytecode. Once the code is written in higher-level programming languages, the code can be compiled to an EVM bytecode. The Ethereum Virtual Machine uses a set of instructions called opcodes to execute specific tasks. Thus, if a user triggers a transaction of 5 ETH using his desktop wallet, the wallet sends the message to the EVM, which connects with the wallet address on the Ethereum network to process the transaction and send it to the receiver. Smart contracts are written in Ethereum-specific programming languages. Let's learn more about these languages. Ethereum languages. Every contract written for Ethereum is compiled into the EVM bytecode and deployed to Ethereum blockchain for execution. Ethereum uses the following languages. The first language is Solidity. Solidity is an object-oriented, high-level language used for implementation of smart contracts on the Ethereum blockchain. Solidity was influenced by Python, C++, and JavaScript. It is designed to target the EVM. The second language is a low-level Lisp-like language. Abbreviated as L, it is one of the original Ethereum smart contract programming languages and is similar to assembly. It is meant to be a very simple and minimalistic language, essentially serving as a tiny wrapper over coding in EVM directly. The third language is Viper, which is a contract-oriented programming language influenced by Python. The fourth language is Serpent, which is an assembly language that compiles to EVM code that is extended with various high-level features. The next language is Muton. Muton is similar to C-like language and supports a dynamic, full higher-level language. It compiles to native Ethereum assembler. However, Muton is now deprecated. The last language is Julia. It is an intermediate language that can compile to various different backends like EVM 1.0, EVM 1.5, and EWASM. Let me now tell you about the accounts handled by Ethereum. Types of Ethereum accounts. Externally owned accounts. EOA is an account controlled by a private key that has the ability to send ethers and messages from it. Following are some of the properties of an externally owned account. Firstly, it has an ether balance. Secondly, it can send transactions. Thirdly, it is controlled by private keys. And fourthly, it has no associated code. Smart contract. Smart contract is a code running on top of the blockchain, containing a set of rules for the nodes to agree upon so that they can interact with each other. As an account, it has the following properties. Firstly, it has an ether balance. Secondly, it has an associated code. Thirdly, a code execution is triggered by transactions or messages received from other contracts. And fourthly, when executed, it performs operations of arbitrary complexity. Some of the advantages of smart contracts are as follows. First, smart contract is the simplest way of implementing decentralization. Second, it provides a high degree of security. Third, it eliminates the need for a third party. Fourth, it provides automatic agreement enforcement. Fifth, it turns legal obligations into an automated processes. And lastly, it lowers the transaction cost. Characteristics of smart contracts. Smart contracts are self-verifying and self-executing. They operate autonomously to execute the terms of the contract and verify the transactions without the need of a third-party intervention. The elimination of third parties reduces the cost of operations and further makes the contracts tamper-resistant. Process of smart contracts. In this slide, we will understand how the smart contract works. First, an optional contract between the parties is written as a code into the blockchain. The individuals involved are anonymous, but the contact is made through a public ledger. Then, a trigger event like an expiration date or a strike price is hit, and the contract executes itself according to the coded terms. Next, regulators can use the blockchain to understand the activities in the market while maintaining the privacy of an individual's position. Let me show you the implementation of smart contract in a simple use case. Smart contract example. Here we have an example showing the purchase and sale of a house. Thus, once a buyer is matched with a seller, all assets are sent into the contract. The contract then distributes the assets based on certain predetermined conditions agreed between both parties and coded into the smart contract. Thus, the settlement is automated and the ownership becomes undisputed due to the transparency of blockchain. EOA versus smart contract. In this slide, we will understand the difference between an EOA and a smart contract based on 4 critical properties. Nonce. In an externally owned account, nonce represents the number of transactions sent from the account's address. However, in a contract account, the nonce is the number of contracts created by the account. The next property is balance. This number shows the amount of WEI owned by the address, whether the EOA or the contract account. Each ether is divided into 1E plus 18 WEI. The next property is code hash. It is the hash of the Ethereum virtual machine code of an account. This is the code that gets executed if this address receives a message call. It is immutable and thus it cannot be changed once the construction is done. For externally owned accounts, the code hash field is the hash of the empty string. For contract accounts, this is the code that gets hashed and is stored as the code hash. The last property is storage root. It is a 256-bit hash of the root node of a Merkle tree that encodes the storage contents of the account encoded into the tree as a mapping from the keycache 256-bit hash of the 256-bit integer keys to the RLP encoded 256-bit integer values. This tree encodes the hash of the storage contents of this account and is empty by default. That was all about the Ethereum concepts and accounts. Let's understand the process of mining now. Ethereum mining. Ethereum mining. Ethereum makes use of proof-of-work mechanism to ensure security. The algorithm used in Ethereum is called Ethash. Each time an Ethereum transaction is made, a miner is responsible for ensuring the authenticity of information and updating the blockchain with the transaction. Let's consider an example where Bob wants to send 1 ETH to Alice. Now we will take a look at the step-by-step process that is followed in order to confirm this transaction through mining. First, Bob attempts to send Alice 1 ETH. Once Bob's transaction is initiated, it is combined with other transactions that have occurred in the last block. The miners will then validate the block with a new set of instructions. Once validated, the miner creates a new block and is rewarded for it. Thus, Alice receives 1 ETH after the transaction is validated. Ethereum mining. The term transaction is used in Ethereum to refer to the signed data package that contains a message to be sent from an EOA to another account on the blockchain. Ethereum blocks contain two things: a transaction list and a recent state of the ledger that comprises these transactions. In the example shown on the screen, we can see a transaction where one wallet sends 20 ETH to another wallet. The diagram shows the previous state and the next state for the transaction. State storage. The states are assembled into a state tree that is linked to the account and the block. The Ethereum includes state roots that store the root hash of the hash tree, which represents the system state when the block was created. Now we will take a look at the step-by-step process to see how Ethereum stores transactions. First, a hash is generated for each transaction. Then pairs are selected and a hash is generated for each pair. This way, the last remaining hash becomes the root. The block header, as seen in the image on the screen, contains the previous block hash and 3 Merkle trees. These trees are to maintain the state, to maintain the transactions, and to maintain the receipts. Also, each block always refers to its previous block's hash. Ethereum ecosystem. Types of Ethereum tools. The Ethereum ecosystem consists of 8 major tools. They are Geth, Ganache, Parity, MetaMask, Mist Wallet, Swarm, IPFS, Whisper. Now, let's move forward and take a look at each of these in detail. Geth. Geth is a multi-purpose command line tool that runs an Ethereum node implemented in Go. It is the official Golang implementation of the Ethereum protocol and is commonly used to interact with the Ethereum network. Though there are several ways to download Geth, the fastest one is to get it from the ethereum.org website. Next, we have Ganache CLI. Ganache CLI. Ganache CLI is a customizable and fast emulator for blockchain, which permits making calls to blockchain without the need for running an actual Ethereum node. Following are some of the properties of Ganache. Firstly, transactions are mined instantly. Secondly, no transaction cost. Thirdly, accounts can be recycled, reset, and instantiated with a fixed number of Ether without the need for faucets or mining. Fourthly, gas price, and mining speed can be modified. Fifthly, a convenient GUI gives you an overview of your test chain events. Parity. Parity is the fastest, lightest, and most secure Ethereum client that provides the core infrastructure essentials for quick and reliable services. Parity is written in Rust language. It offers better reliability, code clarity, and performance. It is an Ethereum client that is integrated directly into your web browser. Apart from allowing the users to access the functions of basic Ether and token wallet, it also serves as an Ethereum GUI browser. It provides access to a diverse range of Ethereum features, including dApps. MetaMask. MetaMask turns Google Chrome into a browser that allows the users to send and receive transactions and also fetch data from the blockchain. It is a browser-based wallet which can be added as a plugin to your Chrome browser. It permits you to run Ethereum dApps directly from your browser without the need for running a full Ethereum node. MetaMask accounts. Practically, it is unrealistic for everyone in the world to run a node to interact with the Ethereum blockchain. To overcome this, MetaMask hosts a number of nodes so you don't have to. A user simply needs to install MetaMask and can automatically get connected to the nodes. Thus, you can use the Ethereum blockchain seamlessly. Let's talk Mist, which is another important tool of the blockchain ecosystem. Mist Wallet. Mist Wallet is the end-user interface for Ethereum that is developed for browsing and using dApps. Mist is an official Ethereum wallet. It was developed and distributed by the team which is responsible for the management of Ethereum ecosystem. It is usually used by developers who want to create, deploy, and use smart contracts. It is a full node wallet, which means you'll have to download the entire Ethereum blockchain onto your computer. Some of the applications of Mist Wallet is as follows. First, sending and receiving transactions. Second, storing Ether. Third, creating multi-signature wallets. And fourth, deploying smart contracts. Swarm. Swarm is a platform which supports distributed storage and provides content distribution services. It acts as a native base layer service of the Ethereum Web3 stack. It provides sufficient decentralization and redundant storage of Ethereum records to distribute blockchain data as well as dApp codes. It leverages the underlying Ethereum infrastructure through the use of contracts and ethers to encourage cooperation among nodes. The files are split into pieces and are stored in the nodes of the network. An accounting protocol is used by peers to keep track of these chunks delivered and received and resulting micropayments associated with it. IPFS. IPFS is a decentralized storage system that is not related directly to Ethereum but can be integrated with it. IPFS stores data by use of a distributed hash table or DHT. Once we know the hash, we request the peer network who has a copy of the content located at the corresponding hash, and then we download the content from the node who has the desired data which we need. The data transfer between the nodes in the network uses a mechanism which is similar to the one used in BitTorrent. It also provides a versioned file system capable of storing files and tracking versions over time. Thus, it defines how files move across a network, making it a distributed file system. By combining all of these properties, IPFS is enabling a new permanent web and augmenting the way we use existing internet protocols like HTTP. Whisper. Whisper is an identity-based communication protocol for dApps to interact with each other. DApps that need to publish small amounts of information to each other and have the publication last some substantial amount of time prefer using Whisper. For instance, a DApp running a currency exchange may use Whisper to record an offer to buy a currency at a pre-agreed price on the exchange platform. Some of the drawbacks of Whisper are as follows. It has low-level API, which is only exposed to DApps and never to users. Second, it has low bandwidth and is not designed for large data transfers. Third, it has uncertain latency. And lastly, it has no reliable methods for tracing packets. Ethereum frameworks. We'll look at two types of Ethereum frameworks. Web3.js. Web3.js is a set of libraries which permit one to interact with a remote or local Ethereum node. It can be done with the use of IPC or an HTTP connection. The key connection between Ethereum network and dApp that allows you to compile, deploy, and interact with smart contracts is called Web3.js. It gives us a way to build a website or client that can talk to the Ethereum blockchain. Let's take an example of traditional development. When you develop a website, it talks to APIs using JSON or jQuery to make AJAX calls. A website talks to blockchain using Web3 using JSON.RPC, which is similar to making a remote procedure call. Ethereum comprises of a large number of nodes which talk to each other. We use JSON RPC to make a request to a particular node, which is like an API. Thus, if we want to talk to a smart contract or read an account, we do it through Web3. ETH.js. It is a highly optimized, lightweight JS utility for Ethereum based on web.js. In this, all the unnecessary characters are removed from the source code and the code is reduced to 160 kilobytes. Ethereum Development Environment. The three commonly used Ethereum development environments include Remix IDE, Truffle, and Embark. Let's understand these environments in a little more detail. Remix IDE. Remix IDE is a browser-based compiler and IDE that enables users to debug transactions and build Ethereum contracts with Solidity language. You can simply log on to the web-based editor, write the code, and compile the same to create the bytecode in order to test your code. The next slide shows how Remix looks. Another popular environment is Truffle. Truffle is a development environment testing framework and asset pipeline for blockchains using the Ethereum Virtual Machine, or EVM. It helps users in developing smart contracts, publish the contracts, and test them. Then we have Embark. Embark is an environment that allows you to easily develop and deploy decentralized applications. It performs the following functions. First, automatic deployment of contracts. Second, keeping track of deployed contracts. Third, managing the complex systems of interdependent contracts. Fourth, performing test-driven deployment with contracts using JavaScript. Fifth, managing different chains like testnet, privatenet, and livenet. And lastly, redeploy the contracts if any changes are done. Let's talk about Ethereum networks. Ethereum network. The basis for decentralized consensus is the peer-to-peer network of participating nodes which maintain and secure the blockchain. A node is defined as a device or a program that can communicate with the Ethereum blockchain network. They are also referred to as clients. They provide wallet functionality and allow users to perform transactions on the blockchain. Thus, a node serves as a machine running as an Ethereum client. It is used to store the data and transfer money. It is formed by combining one or more nodes, and each node contains a copy of the blockchain. Types of network. There are three main types of networks: the testnet, the mainnet, and the private network. Ethereum DApps and DAOs. DApp. Decentralized application is an application that is used on networks with trustless protocols to avoid a single point of failure. They run on a peer-to-peer computer network. All the activity which takes place on an Ethereum decentralized application is cryptographically secured on the blockchain. DApps are open source, which means that everyone can verify the contents of the software. Some properties of DApps are as follows. It uses Ethereum as a development platform. It uses cryptographically encoded blocks. It is not governed by a central server, and there is no master copy of DApp. Let's talk about the advantages of DApps now. Advantages of DApp. Ethereum DApps have the following advantages: improved stability due to a distributed network, higher reliability, automatic credentials assigned through smart contracts, no downtime, no third-party intervention, and high security. Example of DApps. Some of the known examples of DApps include WeFund, Storage, KYC Chain, and 4G Capital. These companies have developed different applications using blockchain. Next, we have the DAOs. DAO. DAOs are organizations designed to hold assets and use the voting system to distribute them. They exist entirely on blockchain and are governed by the consensus protocols. They show the potential of blockchain to revolutionize human social institutions called DAOs. It is an organization run by rules agreed through a consensus process among its members and written in a set of contracts run via a blockchain. It is an open source software capable of modification by its members. Process of a DAO. Now, let's take an example and see how this works. Let's consider that a country is holding elections and wants to prevent fraud in the voting system. A DAO is created to keep transparency in the voting. This is ensured by embedding predefined conditions in the code. People eligible to vote are assigned voting tokens and the voting starts. Every vote is processed on the Ethereum blockchain, and it ensures transparency by allowing everything to run in a decentralized way.
In this video, we will explore Ethereum mining and will go through some of the fascinating concepts and components revolving around it. Ethereum is defined as a blockchain-based computing platform that enables its developers to build and deploy decentralized applications and make sure all the transactions are cryptographically secure in the network. Ether is the cryptocurrency of Ethereum, used to build decentralized applications, smart contracts, and make standard peer-to-peer payments. Ether basically acts as fuel for the Ethereum network. It tracks and facilitates all the transactions. So that brings us to what is Ethereum mining. In simple words, Ethereum mining is a process of creating and adding a block of transaction to the blockchain network of Ethereum. It uses the proof of work consensus mechanism for mining Ethereum. All transactions taking place in the Ethereum network needs to get approved by the miners. Miners is a community of people using a hashing script Ethash to solve computationally hard puzzles for successfully mining the blocks of transactions in the Ethereum blockchain network, which helps secure the network from attacks like hacking or manipulation of identity. Now let's understand why we need to mine Ethereum. The primary goal for mining Ethereum is to make money. Ethereum mining turns the act of securing the network into a relatively complex but profitable business. Also, miners receive a certain amount as a reward for mining each block of the Ethereum blockchain network, including the transaction fees paid by the users. Thus, Ethereum mining benefits each and everyone participating in Ethereum blockchain network. So, what are the types of Ethereum mining? Ethereum mining can be performed in three ways: Ethereum solo mining, Ethereum pool mining, and Ethereum cloud mining. In Ethereum solo mining, you will get rewarded only if you solve the puzzle and mine the Ethereum block first. Since here you are competing with many people and companies, you have to be very good at your work. Also, solo mining is only profitable when you have plenty of resources with you, like 100 plus graphics cards. And in solo mining, having so much equipment may use a lot of electricity and space, leading to high electricity bills, and not everyone has a considerable amount of area needed. Ethereum pool mining is the easiest and fastest way to get started with Ethereum mining. In this, you work along with other people together in a single pool, and if someone from the pool gets the hash code correctly, they share the reward among everyone in the pool. We should consider a few important factors before joining a pool, like pool size, minimum payout, and pool fee. Pool size determines the number of blocks you find in the Ethereum network, and it shares rewards. As the number of miners increases, the chances to get rewards also increase. Minimum payout is the minimum amount of Ethereum you need to mine before it gets credited to your wallet. And pool fee is the amount you need to pay to continue using the pool. This amount is percentage based on the amount of Ethereum you're mining. Ethereum cloud mining, you pay someone else with the equipment to mine Ethereum for you. You pay some amount of money as fees to them for investing their time and resources. And in return, they provide you with the reward they gain by the mining Ethereum. This technique of mining Ethereum has some pros and cons too. Pros, you're not responsible for any equipment damage. You don't have to acquire all the necessary equipment and look for ample space to store it. You can sit back, observe the market, and enjoy the reward for your investment in Ethereum mining. Cons, if the Ethereum price drops, then there is no way you are getting your money back. The money you invested or the fees paid to the miner is lost. And you can't ask the other person to change the equipment according to your concern. Ethereum cloud mining is considered a safer way for mining service providers to guarantee a profit for the resource they have purchased. Now let's understand how the Ethereum mining process works. Ethereum mining follows a specific set of steps to function. Step 1. A user requests a transaction with the help of the private key of his digital wallet account. Then the request is shared worldwide with the Ethereum network. Next, the requested transaction is added to a list of pending transactions that needs to be added to the Ethereum blockchain network. Step 4. The miner then verifies and validates the requested transaction and perform a complex mathematical puzzle on the transaction data. Step 5. Once the request transaction is verified and it stores a copy of it in Ethereum, the process of proof of work begins for the respective block. Step 6. When the nodes of the Ethereum network verify that the checksum of the state of the miner's block matches the checksum of the updated state of the Ethereum after execution of all transactions. Step 7. Only after that the block is added to the Ethereum blockchain network. Step 8. On successfully mining the block, it rewards the miner with some amount of Ether in their wallet. The block reward of Ethereum is 3 Ether. And step 9. The requested transaction is approved and credited to the respective wallet or wallets. Each transaction is mined only once, but every participant of the Ethereum network verifies it. This makes me curious about how to mine Ethereum. Tools you will need to be an efficient miner for Ethereum on your personal computer are an Ethereum wallet to store all your currency earned, GPU drivers or graphics card with a minimum of 3 GB RAM. A mining software suitable according to your hardware like GPU. And a compatible operating system, Windows 7 or 10 with 64-bit. Before getting started with mining Ethereum, you need to create an Ethereum wallet to store all your Ether. Trezor Model T and Ledger Nano are the most reliable and secure wallets in the market of cryptocurrency. Installing GPU drivers or graphics card after creating your digital wallet, you need to update all the hardware, that is, drives in your system. You can use two types of graphics card. They are AMD graphics card and NVIDIA graphics card. Claymore is considered the best software for mining Ethereum on GPU drivers. Now, we need to follow a few set of steps to get started with mining. Step 1. Download the latest version of Claymore Dual Miner for the operating system. The latest version is Claymore 11.0. Step 2. Click on the latest version for Windows and download the zip file. Step 3. Extract the files of Claymore 11.0 to a folder on the desktop for easy access. Open the folder to have a look at the files. Step 5. Right-click on Start and then on the Edit option. Step 6. Edit the start.txt file and add these lines. Step 7. Choose your desired pool from these recommendations. You can also find better search results than these according to your region. Step 8. Type in your pool address instead of mining pool address. Step 9. Save your start.txt file with your new updates. Remember, while saving, select Type as all files. And step 10. Once you save, click on the clay.bat file to begin mining Ethereum. Now let's explore will the proof of stake transition fail proof of work. The newly introduced concept of Ethereum 2.0 roadmaps plans to upgrade to proof of stake consensus algorithm in which it will provide all existing miners of Ethereum network with a limited time to earn a return for their investment. This is expected to be launched by the end of 2021 or the starting of 2022. It was supposed to be launched by October 2020, but the history of delays regarding this upgrade is worth talking about. Nobody truly knows when Ethereum 2.0 will be completed and introduced to the crypto mining world. Now, when we know all about Ethereum mining, this makes me wonder if Ethereum mining is profitable. The profit of any crypto mining majorly depends on the cost of electricity in that particular area. As a rule, anything below $0.12 per kilowatt consumed in an hour is considered profitable. You can mine Ether and turn it into a vital source of income by analyzing these figures like hash rate of Ethereum, block reward, number of blocks per day, and the coin price of Ethereum. You can also use an Ethereum calculator to figure out your daily revenue, basing it on these factors. Or you can use this formula too. The predictions are made that the Ethereum price can rise and become more stable in the coming few years. So it is an excellent opportunity to invest in and save in Ethereum.
Now, why smart contract? Now, let's take a look traditionally how contracts used to happen. If suppose two parties, A and B, have to get into a contract, they will utilize the services of a third party whom they have to trust and get the contract executed. Now, with the introduction of smart contracts and the technology which is evolving, removes the dependency on such third parties and automates the execution of such smart contracts. So, if we compare traditional versus the new smart smart contract. In traditional, we used to have governments, lawyers, or any other third party on which we can trust. In smart contracts, we don't need any third party. We don't need any intermediate. Execution time, definitely there's higher execution time in traditional contracts because as many number of middlemen and their intermediary layers, that many number of days and time it takes. Smart contract is just a matter of minutes. It gets executed because it is automated, programmable, running on a computer, and it has some predefined condition. Remittance. If any remittance of either of the parties have to happen, then it's a manual process. Approvals, workflows, processes, and these manual processes take time under traditional contracting system. But in a smart contract, as the conditions are predefined, pre-embedded, as soon as a condition is met, the remittance happens automatically. Either of the parties who have to be credited with an amount is credited automatically, and that is the primary advantage of using a smart contract. Transparency is not available 100% in traditional contracts. The transparency is bound, peripheral between the parties and the entities and the intermediaries involved. As compared to smart contract, transparency is 100% available 24/7 online. Anyone can go and review, audit, and validate the transactions executed by the smart contracts. Archiving. Archiving is a big difficult problem for traditional contracts as most of the transactions are paper based or the records are maintained offline. It becomes very difficult to maintain and identify the traceability, provenance of all the transactions which have happened in a traditional contract, whereby in a smart contract it becomes easy as all the transactions have happened through the smart contract. There's 100% traceability available. From the provenance point of view, you can trace the transaction from its day one, the point of origin, till present day, and archiving is automatically happening. The log, the audit, the transaction history is automatically getting generated. Security definitely is a concern in traditional contracts as the intermediaries are involved, manual processes are involved. Security can be compromised at any level, at any stage. But in a smart contract, the security is maintained through cryptography, mainly through public key infrastructure, the public and private key infrastructure. It is a very secure way of maintaining security and cryptography of the transactions using a smart contract. Cost, yes, traditional contracts are expensive. The cost of transaction is high as compared to smart contracts as the middlemen are involved. Smart contract, the cost is low as we don't have any intermediaries and only the cost of transaction is charged by the underlying infrastructure of the blockchain network which is running the smart contract. Signatures, it's a manual process. All the transactions are signed manually and verified manually, but here in the smart contracts, all the transactions are digitally signed using the private key of the entities and can only be decoded by the public key shared by the parties involved in the smart contract. So in a nutshell, smart contracts give us n number of advantages. The primary advantages are listed here, and these are the advantages which enforce us to move towards an economy and to a system where we start using smart contracts for our transactions to avoid any disputes, to keep the transaction cost low, thereby giving the advantage to the end consumer. Now, what is a smart contract? Let's consider a real life example where you are taking out a chocolate from a vending machine. You deposit a $2 note in a vending machine. After that, you hit A1 button, which is mapped against the chocolate bar that you want to buy. As a result, a lever in the vending machine moves and pushes out the chocolate. So basically, A1 button is programmed to the lever in order to move the chocolate out. Now, a smart contract is very similar to a vending machine. It eliminates the need of an intermediary. In case of the vending machine is replacing a direct seller and allowing you to make a purchase without a middleman, and it eliminates the need of escrow services. Now, smart contracts are self-executing contract which contain the terms and conditions of an agreement between the parties and the peers who are involved in that agreement. So the terms and conditions of an agreement are written in a piece of code and it is executed on a blockchain based decentralized platform. Now these agreements facilitates exchange of any digital asset. It could be digital currency, it could be shares, it could be property, or it could be anything which you want to transact. So a blockchain based decentralized platform gives you a democratic system where the transactions are authorized by the majority of the participants and the identity of the participants is also kept anonymous. Now let's consider an example where Rachel is at the airport and her flight is delayed. But this inconvenience could have been beneficial to Rachel, as smart contract insurance would ensure she is given a compensation for the flight's delay instantly. So just imagine there is a smart contract which the insurance company has already deployed and it's monitoring the flight's delay. Rachel has already taken that insurance for delay in flights. So as soon as that condition is met for a delay of flight above X amount of hours, for example 2 hours, then in that case the insurance company will automatically get that trigger and Rachel will be credited with that amount for which she is insured in her account. So let's see how smart contract can be helpful here. So AXA flight delay insurance is one of the examples of Ethereum smart contract. AXA is an insurance company. The smart contract is linked to the databases that record flight status. So that smart contract is connected to the databases. It is fetching that information and evaluating the delay. It enables automatic compensation when there is a delay for 2 hours or more. So that is the condition. When the flight delay is beyond 2 hours, then the insurance contract will get executed and Rachel will get paid. So a smart contract is created based on the terms and conditions. So condition compensation is equal to flight delay is less than 2 hours. Based on the code, smart contract holds the company's money until a certain condition is satisfied. This smart contract is submitted to the nodes on the blockchain network to their EVMs for evaluation. So EVM is a runtime compiler to execute smart contracts code. It is the brain. It is the electronic virtual machine which executes the smart contract. All nodes on the network executing the code using the EVM must come to the same result because all the EVMs would have the same copy of the smart contract deployed. So if the flight is delayed 2 or more hours, smart contract will be self-executed and the compensation amount will be given to Rachel, and that is the objective of the smart contract without involvement of any middleman, paperwork which Rachel has to do to submit, and then the insurance company going through the manual process. All that has been bypassed and Rachel has been compensated directly. Now let's understand why do we need Solidity for developing our smart contracts. Now here comes the important question. Which programming language does a smart contract use? There are two widely used programming languages for writing Ethereum smart contracts: Solidity and Serpent. However, on blockchain platform, Solidity is widely used for implementing smart contracts, and this is what we are going to talk about in our subsequent slides. Now, Solidity is a high-level programming language used for implementing smart contracts. It enables to check the program at runtime rather than compile time. Solidity is a Turing complete language. It has all the conditions, all the while loops, for loop, operators, etc., which are there in any matured programming language in order to write your code, in order to write your conditions, if you have certain loop, if you have while conditions, etc. Now, what are the advantages of smart contract? As we have already discussed, there are no intermediaries involved. The process executes without the need of a third party. It's an automated process. They are automated with the code which eliminates manual effort for execution. It's a high speed, highly computive smart contracts which runs on programming code. The speed of its execution is higher than a traditional contract. As the data is stored in the decentralized system, the chances of modifying the data is difficult, and I would say more than impossible. Accuracy based on the requirements, terms and condition of a contract is recorded accurately. So as soon as any transaction is recorded, it is registered on a blockchain network and it is immutable transaction. No one can modify or make changes in any record which has been added onto a blockchain network through a smart contract. Now let's take a look at certain blockchain implementation of a smart contract. Using blockchain in voting process can eliminate voting malpractices. A centralized voting system faces a lot of problems when it comes to tracking votes. There could be manipulated identities, there could be manipulation in counting, and there could be biased decision making. A smart contract is introduced to eliminate all these malpractices. There are certain predefined terms and conditions which are already set in the contract. No voter can can vote from a digital identity of any other voter. The counting is foolproof. Every vote is registered on a blockchain network and the counting is happening automatically without any interference from a third party or dependency on a manual process. So terms and condition, each ID should be attributed to just one vote. The validation is done by the users on the blockchain network itself. So the voting process can be in a public blockchain or it could be in a decentralized autonomous organization based blockchain setup also, but it is 100% transparent and every voting transaction is recorded. Result, every voter's vote get recorded on the ledger and that information cannot be modified. It is transparently publicly available for audit and verification. Now let's take a look at one of the examples of our voting solidity contract. So here we have our voting solidity contract. It is built in Solidity and I'll just give you a brief overview of what are the primary functions in this. So if we look at this particular contract, this contract gives you certain basic parameters like what should be the minimum number of participants or proposals which are required for voting. Then what should be the minimum amount of time for debate that needs to pass before the vote can be executed. Then the margin of votes for majority A proposal passes if there are more than 50% of the votes plus the margin. So basically we are defining what is the winning condition, what is the majority margin for any vote to be accepted. Then you have data structures where you are accepting the proposals, right? And then subsequently we are defining data structures for members who are participating in the proposals, who are submitting the proposals. We are fetching the addresses of the members. Basically this is the digital identity of the members who are submitting the proposals and etc. So the smart contracts basically allows you to create a voting system where you can add members, we can remove the members, you can change certain voting rules based on certain conditions, like if you want to increase the minimum quorum, if you want to change the debating period minutes or the majority rule changes. Then this is a function for submitting a new proposal for which the voting has to happen. So basically this example is about if I have to take a vote within a decentralized autonomous organization for a particular decision. So rather than a central authority taking a decision, you can have a voting mechanism within your organization to give a majority to your proposal. If you get the majority, the proposal is accepted, otherwise rejected. Then there are peripheral functions like check proposal code. Then there is a voting function. The actual vote happens, and for a particular proposal, you start increasing or decreasing the number of votes. Then you execute the proposal if the majority has been achieved. Now let's take a look on how to deploy a smart contract. So here we have our voting smart contract. Now we will take a look on how to deploy our voting smart contract on the Ethereum test network called Ropsten. This is our voting smart contract. Now, when you open Remix, you should also have MetaMask, which is a Chrome plugin installed. This is a utility in order to connect to the Ropsten testnet, which is an Ethereum test network. So basically you say ropsten.etherscan.io, and this is the Ethereum test network on which we will deploy our contract. So once you log in into the MetaMask, you will have an account created, and in that account, you should have some test ethers already so that you can use them to deploy your contract. So when you create an account on Ropsten, you can buy certain ethers using the Ropsten test faucet. So when you reach this site, the Ropsten test faucet has already taken the address for the account for which you are raising the request, and you can raise request of 1 ether. Now whenever this transaction will get processed, your account balance will get incremented by 1. So as I already have ethers in it, I can utilize it to deploy my contract. Now in order to compile and deploy my contract, I have copy pasted it here, and if I go to my run, my Remix has already communicated via injected Web3 to the MetaMask and taken my account, which has 7.83 ether. Now I need to do some settings. Now, as my contract is compiled, you can see it has taken all the contracts. You can see the drop down, and Congress is my major contract. Now, I will deploy my contract. So on the run section, you will be able to see in the drop down the name of the contracts which are there in my smart contract. Like I had owned, token recipient, then there's an interface and there is a Congress. So I need to deploy my Congress contract. Now in order to deploy this contract, there is a constructor which requires certain inputs. So I can give certain values like what minimum number of proposals I need, 100, then minimum number of debates, 10, and margin of votes for majority. So I say deploy. Now as soon as I'll click deploy, it is going to request me for gas, because when the contract gets deployed, it will deduct certain ethers from my account. So when I'll say submit, if you notice, now this transaction has got initiated on the Ropsten etherscan.io. I click on it. So this is the transaction on which the contract is getting deployed. It is taking time and the contract is getting processed on the Ethereum network. Now once it will get deployed, we will be able to see the address at which the contract has got created and deployed. Now as you can see, my contract has got deployed at the address 0xcc. I can load it. Now this is the contract address and this is the amount of actual ether which was spent from my account in order to deploy the contract. Now there are certain attributes on the Ropsten Etherscan which you can go and check. You can verify and publish your smart contract over here so that others can also view the code and utilize your smart contract. And if you go and check your MetaMask, this is the transaction which has just been done in your account, and if you click, it will take you to the same transaction which we opened here. Now after you have deployed the contract, you can interact with your contract directly through Remix. Just to test your contract, all the pink members are the ones which make changes onto the blockchain, and all the blue ones are the ones which are only performing read operations. So in order to do any read operation, you will not be requested to spend any gas. So there will be no pop-ups for MetaMask requesting for gas spending. But if you do any of these pink actions, then you will be required to spend gas, as it will be requiring to make some changes onto the blockchain. So this was a example of a voting smart contract, and this will be available as a link for you to take a look at. Now all our other contracts which we will be covering subsequently will be deployed in a similar fashion on the Ropsten testnet. Now let's take another example. If you want to use smart contract to issue your own cryptocurrency or called digital token, you can use Ethereum based smart contract to create your own digital tokens for performing transactions. Aim: design and issue your own digital currency. Create a tradable computerized token that can be utilized as a currency, share, or any asset which you want to transact. These tokens use the standard coin API. Like in case of Ethereum, we have standardizations of ERC20, etc., which allows contract to automatically access any wallet for exchange. As a result, you build a tradable token with a fixed supply, and this particular platform becomes like a central bank issuing a digital money. Your smart contract becomes the bank issuing the money. So let's take this example here. So this is a implementation of a ERC20 token, which is a specification by Ethereum, and the primary attribute for this token is that you need to provide a name of your token, a symbol, the decimals to which you support, and the most primary is the predefined supply. So just like in an economy you have limited supply of money, here also you have to define what will be the supply of your tokens, and it will be capped. That will be the supply. So you need to predefine these parameters, and then you create certain data structures within Solidity to keep a tab on the balances of the entities to which you are giving the tokens and how much allowance you want to keep per address. Then there are certain methods which you have to implement as per the ERC20 specification, like transfer, transfer from, approve and call, etc. So all these methods in a typical token allows you to do the transaction, send and receive your custom token among multiple parties. So this would also be available as a link for you to take a look. Now let's take another example of a use case for crowdfunding, using smart contracts to crowdfund your project. So suppose you want to start a business, and for a business you need a lot of funding which is required. But who would lend that money to someone whom they don't trust? How will you generate that money? For such problems, smart contract plays a major role. With Ethereum, you can build a smart contract that will hold a contributor's funds unless a given date or a goal is met. Based on the result, the funds will be released to the contract owners or will be sent back to the contributors. So basically you can create a crowdfunding project for yourself if you want to raise certain amount of money, and the contributors or the investors will give you the money, but the amount will be kept on hold till the time your project goal or date has been met, and accordingly the investor will get the token which you have developed for crowdfunding in hers or his account accordingly. Now, centralized crowdfunding system has plenty of issues with management systems. So therefore, a DAO, a decentralized autonomous organization, is utilized for crowdfunding. The terms and conditions are transparently set in the contract. Every individual participating in the crowdfunding is given a token, and the token is credited to their Ethereum based account. Now, every contribution gets recorded on the blockchain, because when the token transfer has happened from the DAO to the individual investor, that transaction gets recorded on the blockchain network. So let's quickly take a look at the contract for a crowd sale also. So a crowd sale contract provides you the basic attributes like what is the goal of the funding, how much money you need to raise, what is the amount raised real time, you can keep a track, what is the deadline, right, and what is the price of the token in Ethereum. Basically, what is your token amount in Ethereum. Then there could be that you might give certain tokens in reward, then you can have attributes for your reward, and then you have your methods in order to keep a check that once you have received the funds, you can withdraw the funds, you can check whether you have reached the goal for funding, and then you have the methods for transferring tokens from the sender to your own account. This particular kind of contract allows you to maintain and keep a check on amount of funding you have received or you want to receive. Have you achieved your target? Who are the investors in your token? How much percentage share belongs to your account and how much percentage share has been already been distributed amongst the investors, etc. So everything can be tracked. So the smart contract can build in such a fashion that there are methods and utilities available in order to run your entire crowdfunding.
In this video, we will explore Ethereum 2.0 and will go through some of the fascinating concepts and components revolving around it. So what is the Ethereum network? Ethereum is defined as a blockchain-based computing platform that enables its developers to build and deploy decentralized applications. Ether is the cryptocurrency for Ethereum, used to build decentralized applications, smart contracts, and make standard peer-to-peer payments. It tracks and facilitates all the transactions and makes sure they are cryptographically secure in the network. Ether basically acts as a fuel for the Ethereum network. So what is Ethereum 2.0? Ethereum 2.0 is a set of interrelated upgrades that will make the Ethereum network more secure, scalable, and sustainable. Multiple teams from across the Ethereum ecosystem have come together to work on these upgrades in Ethereum 2.0. Then, what led to the origin of Ethereum 2.0? With growing popularity, Ether and the Ethereum network has gotten more blocked by transactions. Currently, it is capable of handling 15 to 45 transactions per second, which is comparatively impressive, but it is not enough to handle all of Ethereum's users worldwide. Also, the high demand is affecting the driving up of transaction fees. Nodes power the Ethereum blockchain network, but currently its nodes are experiencing too much volume. Although the programmers working on the upgrade have claimed that making its nodes bigger wouldn't be practical. Ethereum 2.0 intends to make the network more scalable to handle all of the activities on the Ethereum network. That makes us wonder, what are the changes in Ethereum 2.0? The two significant changes that will come with the upgrade are adopting proof of stake and sharding. Adopting proof of stake, Ethereum blockchain implementations suffer from performance issues because They rely on a processing power intensive process known as proof of work to record and validate their transactions. The problem with proof of work's design is that it's very inefficient. Ethereum 2.0 will solve these issues by transitioning its blockchain to a more efficient proof of stake system. It will decrease the complexities faced by the network, leading to massive throughput gains for the whole network. Sharding is a process that intends to enhance Ethereum's efficiency and ability to scale. In the current version of Ethereum blockchain, all data that is added to the chain undergoes verification by all participating nodes. That means that the speed of its slowest participant limits the processing speed of the entire network. Sharding will increase the efficiency of the network resources by breaking data verification tasks among its set of nodes. And each of them will be responsible for validating and verifying just the data allotted to them. This will increase the network's overall capacity and make it much faster and efficient than its outdated version. So what is the current status of Ethereum 2.0 research? While Ethereum 2.0 has been in research and development since 2014, it has actually been making some progress. The Beacon chain went live in December 2020, introducing the staking concept, but still there is no official claim for the completion of this transition. The next phase is mainnet, merging the Beacon chain into the current Ethereum network. Mining Ethereum tokens will officially end in this phase, and staking will become the primary way to create new tokens in the Ethereum network. The last part of the transition is expected to unfold in multiple phases, like adding the shard chains to give the Ethereum blockchain network more capacity and efficiency to handle all of the demand and increase transactions per second. Although it has been a long road and there is still a good deal of uncertainty around the timing, the Ethereum developers do seem to be motivated and on their way to completing the whole transition. So, what is the future of Ethereum 2.0? If executed properly, this transition to Ethereum 2.0 could be a total game changer. It will create a modified network that could potentially process 1 lakh transactions per second, and a much more sustainable network without the energy-intensive mining process. And it will introduce smart contracts worldwide, increasing the Ethereum's network utility. Furthermore, Ethereum co-founder Vitalik Buterin once said that the issuance of new token should be highly reduced under Ethereum 2.0, which could increase its demand. Given all these factors, Ethereum 2.0 seems to hold a bright future for Ethereum blockchain network. Did you know there are more than 1600 cryptocurrencies worldwide? And among them, Bitcoin and Ethereum have always been the top 2 most popular cryptocurrencies in the world by market cap. Also, recently, Ethereum as well as Bitcoin reached its all-time peak in worldwide trading. According to Decrypt.co, every day new companies like Me2 and PayPal are coming forward to invest in Bitcoin and Ethereum. On March 7, 2021, Me2 confirmed that it had purchased 40 million in Bitcoin and Ethereum. On the other hand, PayPal is about to launch a scheme where the public can purchase and sell cryptocurrencies, initially featuring Bitcoin and Ethereum via PayPal digital wallet. But have you all ever wondered how they compare based on their similarities and differences in various aspects? Well, before moving any further, let's have a quick look at how Bitcoin and Ethereum originated and made a benchmark in the economic system worldwide. Bitcoin was first introduced in 2009 by Satoshi Nakamoto to resolve cyber attacks, double spending, and eliminate the middleman between the transaction. It led the first revolution of digital money, which enables transparent and decentralized peer-to-peer transaction. On the other hand, Ethereum came into the picture years after Bitcoin. It was first introduced in the late 2013 by Vitalik Buterin. After that, it was very quickly and widely adopted because it offered a platform to build and run applications without any downtime, fraud, or interference of any third party. Ethereum serves as a computing platform that enables its developers to build and deploy their decentralized application. Now, let's move ahead and see the difference between them which make them compete with each other in this economy. This video will cover individual aspects for comparing Ethereum and Bitcoin's performance in that particular field. By time, Bitcoin has proved itself as a well-known cryptocurrency. However, Ethereum with different functionalities is giving a quite tough competition to Bitcoin. But before moving ahead, let's have an introduction to Ethereum and Bitcoin. Ethereum is a platform that builds immutable smart contracts, an application for its users without any centralized interference. For Bitcoin, it is an alternative to fiat money or physical currency. The main function of Ethereum is to provide its users or developers with a platform to build smart contracts using dApps or decentralized application. On the other side, Bitcoin only intends to be a medium of exchange of money and value stored in its blockchain network. Now let's get started and move towards the first comparison, which is algorithm. Ethereum uses the Ethash cryptographic algorithm for mining blocks in the Ethereum network. On the other hand, Bitcoin uses the SHA-256 hashing algorithm for mining blocks in the Bitcoin network. Ethash algorithm is mainly used during the proof of work function. Proof of work is a small piece of data that is difficult to generate but easy to validate and satisfies certain network requirements. SHA-256 algorithm helps Bitcoin users to protect all their sensitive data like private keys. Moving on, the programming language of Ethereum and Bitcoin. Ethereum uses Solidity. Solidity is a high-level programming language used by Ethereum for implementing smart contracts. But in terms of programming language, Bitcoin keeps it simple. Bitcoin uses C++ as its programming language. It is a stack-based programming language used to give Bitcoin software instructions on how to make transactions. As we have covered the algorithm and programming language of both cryptocurrencies, now let's take a look at the mining process of both. Mining is a process in which transactions made are validated and added to blockchain public ledger in blocks, and the people mining these blocks are called miners. Ethereum miners mine the unvalidated transaction using the proof of work method, but it aims to switch to proof of stake because it will make its network more immune to centralization, energy efficient, and stronger support for its shared chain. On the other hand, similar to Ethereum, Bitcoin miners also use the proof of work method to mine unvalidated transactions. This method is enough to function in Bitcoin network worldwide. Now let's proceed towards the monetary policy of both cryptocurrencies. But let's first understand what monetary policy is. Monetary policy is known as the process of drafting, announcing, and implementing the plan of actions taken by the competent monetary authority to control the money supply and achieve goals that promote sustainable economic growth. So, Ethereum's policy is defined by the reward paid out by its protocol. Ethereum's monetary policies are best described as minimum issuance to secure the network. Therefore, there is a constant trade-off between the transaction speed and security. But Bitcoin's monetary policy comprises of two parts, halving and block frequency. Halving event is when the reward of mining Bitcoin is cut in half, and it also cuts the inflation rate. And the block reward is the number of Bitcoins you get if you successfully mine a blockchain block. The current block reward for Ethereum is 2 Ether per block, and for Bitcoin, the block reward is 12.5 Bitcoins per block. Also, every 14 seconds, a block of Ethereum is generated, and one block of Bitcoin takes 10 minutes to generate. Monetary policies are considered to be fixed and non-inflationary. Due to this, over time, mining blocks will become more difficult. Next is transactions. Ethereum is a little bit faster than Bitcoin, with 30 transactions per second, and it takes just a few minutes to confirm it. On the other side, Bitcoin's transaction speed is 5 transactions per second, and it can take up to 60 minutes or more to confirm. Ether, the currency of Ethereum, acts as the fuel for Ethereum networks, and Bitcoin is only used as the value for real-world transactions. To compete with already present electronic cash like credit cards and Google Pay, Ethereum and Bitcoin require higher productivity to attain widespread adoption. Not talking about the availability of both cryptocurrencies, Ethereum is not limited, but it can occasionally reduce due to large network upgrades. However, Bitcoin is limited to 21 million coins, and as of today, 18 million Bitcoin is already used. But in the end, both Bitcoin and Ethereum, being the top cryptocurrencies, share a few similarities. Like both are decentralized and can be used to have a peer-to-peer transaction, proof of work also, both have a large network of independent nodes.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now, let's have a demo. Now, let's have a look at the media outlet website CoinDesk, where we will see all stats related to Bitcoin and Ethereum in detail. CoinDesk is a site specialized in digital currencies. It is used to explore the news and price data related to cryptocurrencies, and also explains how cryptocurrencies contribute to the evolution of financial system worldwide. Now, see this graph. This graph shows the change in Bitcoin price in 24 hours duration. This graph shows the gradual change in the price of Bitcoin. It started from $64,439.29 on April 14 at 12 p.m. And right now, by April 15 at 6 a.m., it is at $63,189. The rate of change is minus 0.46%, which shows the change in the price of Bitcoin per hour. Let's have a look at this graph of Ethereum too. The value of Ethereum started at $2,388.13 on April 14 at 12 p.m. and the current status on April 15 is positive with a value of $2,442.37 with an increasing rate of 4.67%. Down below, we have a metrics table that shows the change between the starting and ending value of Ethereum, the total supply of a cryptocurrency in 24 hours, the total number of transactions that occurred, and the average transaction fee for all these transactions. Now, this graph shows the current status of cryptocurrency in USD dollars. We can also see its value according to any centralized currency like Euro or INR. This graph shows the constant trading change in the value of cryptocurrencies every moment. We can also access the data of trading from an hour to its lifetime. Recently, we all have been hearing about a cryptocurrency famously known as Dogecoin. But what exactly makes it so different from others that almost every person is talking about it? So let me tell you that Dogecoin is an altcoin and an almost sarcastic meme coin that serves as a peer-to-peer open source cryptocurrency. Well, that's not enough. So let's dive down and understand the concept of Dogecoin more precisely. But before starting, let's have a look at why is it in the news. Since the beginning of the year 2021, Dogecoin has surged more than 950% from less than half a penny to more than 5 cents per Dogecoin. Then Elon Musk, CEO of Tesla Incorporation, took his interest in it and tweeted, "Too much concentration is the only real issue for cryptocurrency, making the owner of the Dogecoin wallet a subject of attention." Later on, other celebs like Snoop Dogg also started taking an interest in Dogecoin and started tweeting and promoting it on social platforms, which made Dogecoin climb to a peak of 8.2 US cents and market capitalization of $10 billion. In this video, we will come across the following topics. First, we will see the origin of Dogecoin, and then we will understand what is Dogecoin, how does it exactly works, and then we will see what led to the growth of Dogecoin. What are the areas of uses of Dogecoin? Then we will figure out what is the current value of Dogecoin today. And lastly, how can we buy it? Let's start with the origin of Dogecoin. Dogecoin was invented by two software engineers, IBM engineer Billy Marcus and Adobe engineer Jackson Palmer. Did you know that they never even met before combining the two most significant phenomena of the year 2013, Bitcoin and Doge? Well, now let's move ahead and see what is Dogecoin. Dogecoin is a peer-to-peer open source cryptocurrency that provides its user a completely unknown, decentralized and secure environment free from any third-party interference to make their transaction. Dogecoin was intended to be an altcoin and a meme coin inspired by Shiba Inu's popular meme aka Doge. Moving ahead, let's have a look at how it works. To understand the workflow, let's take the example of two friends. Mark and Susan. Mark owes some money to Susan, and now he needs to return it. So he thinks of an idea and decides to send her Dogecoin instead of giving her physical money. They both open their digital wallet account. To pay her, he needs two essential pieces of information. First, his private key, and second, her public key. To get access to Susan's private key, he needs to scan a QR code from his smartphone. Then the application alerts all the Dogecoin miners around the world to proceed further with the process. The Dogecoin miners validate whether Mark has enough Dogecoin to make the payment or not. And after the validation process, they approve the transaction request. Dogecoin miners race with each other to collect all the data of the pending transaction known as the nonce. The miners then apply a mathematical function to produce the correct hash number for that particular nonce of the pending transaction. The miner who successfully produces the correct hash number is rewarded with 25 Dogecoin in his account. After that, Mark and Susan gets a confirmation message that their request for the transaction has been approved, and within 10 minutes the requested amount of Dogecoin is credited into the wallet of Susan. Thus, the transaction is completed. So, what led to the growth of Dogecoin? Dogecoin officially came live in 2013 and became an instant hit within the community of people who just wanted to play around with the cryptocurrencies freely. As I said earlier, Dogecoin was intended to be a joke for content creators, but they were very well received it. Users of internet forums like Reddit and Twitter adopted Dogecoin and started tipping their content creators. This usage of Dogecoin made it surpass the trading value of the other cryptocurrencies, specifically Bitcoin, in 2014. It also started doing charity work to introduce and promote themselves in the real world. For example, once they raised a fund of $55,000 for a NASCAR driver, Josh Weiss, and in return, he printed the logo and 98 Dogecoin over his race car. Eventually, it almost became the mascot for what crypto should be. Let's have a look at who uses Dogecoin. Today, many companies and firms like restaurants, grocers, web hosting, products retailer, ebook sellers, and travel services uses Dogecoin for transaction. These are a few examples of companies in every sector that uses Dogecoin. Grocers, Hello Pets, GamerHeats.com. For web hosting, Gamer. For products retailer, Meltdown and Nordex. Ebook seller, Cornell. And travel services like Velolio.it. This makes me curious about the current value of Dogecoin. Let's have a look at that too. According to the market cap today, the current value of Dogecoin is $0.059357 USD with a trading volume of $16 billion. The circulating supply of this cryptocurrency is 129 billion Dogecoins, and the max supply of Dogecoin is not available. How can we buy Dogecoin? So to buy Dogecoin, we will have to follow a few steps. Step 1. Open a digital wallet. Buy Your Coin is considered a perfect application for trading cryptocurrencies. Step 2. Register your account. Step 3. Complete your profile KYC by providing your identity and address proof, like Aadhaar card. Step 4. Add your bank account details. Step 5. Secure your account by creating a convenient trading PIN that is only accessible by you. And step 6. There you go. Now you can start trading. That is all about Dogecoin. Currently, we have heard a lot of buzz about the cryptocurrency Dogecoin and the shenanigans of its community. Did you know that on 20th April 2020, Dogecoin surged its value to $1, making this day named after itself as Doge Day? The supporters of Dogecoin were trying to amplify the value of it to make it $1. But how is it done in reality? How can we affect the value and availability of cryptocurrency? Well, all this is done by a process called mining. And this is what affected Dogecoin, resulting in the rise of its value. Mining coins of the Dogecoin network is called Dogecoin mining. So let's get started and have a quick look at what is Dogecoin. Dogecoin is a peer-to-peer open-source cryptocurrency that works on blockchain technology. Also, it provides its users a completely unknown, decentralized, and secure environment free from any third-party interference to make their transactions. Dogecoin uses cryptography to secure all its transactions. This makes me curious to know what is the net worth and availability of Dogecoin today. According to market cap, today the current value of Dogecoin is $0.266247 USD. The circulating supply of this cryptocurrency is 120 for mining Dogecoin. That makes me wonder what the difference between Dogecoin mining and other cryptocurrencies mining process. Let's have a comparison between Dogecoin mining and the Bitcoin mining process. We will be comparing these crypto mining based on these factors. First, algorithm. It is a set of rules that every cryptocurrency follows for mining new coins. In the algorithm, Dogecoin mining uses Script. Bitcoin mining uses SHA-256. Script is considered a lot quicker and cheaper than the SHA-256 algorithm, making mining easier for miners of the Dogecoin network. Second is difficulty. This represents the complexities and challenges faced by miners to mine each block of the blockchain of any cryptocurrency. In difficulty, Dogecoin is 2,798,252. Bitcoin is 3,511,60,552,899. Thus, it proves that Dogecoin is easier to mine among other cryptocurrencies. Third is block time. It is the time taken by a new block of transactions to be checked, confirmed, and added to the blockchain. Block time of Dogecoin is 1 minute. For Bitcoin, it is 10 minutes. And at fourth and fifth, we have reward per block and per block USD. It is the amount in USD to the miner for each block added to the network. Block reward for Dogecoin is 10,000 Dogecoins per block, which in USD is 27.36 Dogecoins. For Bitcoin, it is 12.5 Bitcoin per block, and in USD, it is 86,391.63 Bitcoins. Moving on, finally, we have reached the most crucial point of this video. Now we will have a look at how to mine Dogecoin. Dogecoin can be mined in two ways. The first one, Dogecoin pool mining, and the second is solo mining. A Dogecoin pool is a group of people who share their computing power to mine Dogecoin transaction data and get rewarded by equal share after confirming the transaction. Solo mining is when only one person does all the work of mining and confirming transactions. The reward is awarded only to that person after confirming the transaction. Let's have a thorough discussion of the difference between Dogecoin pool mining and solo mining. In Dogecoin pool mining, you have to mine as a part of it and pay fees. In Dogecoin solo mining, you don't need to pay any fees and you mine all by yourself. Also, in pool mining, you will only get a part of the reward earned by the pool. But in solo mining, the total reward earned will be received by you only. As in pool mining, many people work together, so they mine blocks more often. And on the other side, solo mining could take a lot of time before one mine their first block. In pool mining, it takes less time to confirm a transaction as you work as a part of the pool community. On the other hand, in solo mining, it can take much longer to confirm a transaction as you do all the work and there is a lot of competition. So this was all about Dogecoin pool mining and solo mining. Let's proceed further and see what we need to start mining Dogecoin. But before we start mining, we will have to make sure that we have these things with us. A PC with any operating system like Windows, Linux, Ubuntu, etc. A good internet connection, and a digital wallet to store the Dogecoins you mine. Which hardware and software can we use for Dogecoin mining? You will need your PC's CPU, which should be powerful enough to mine Dogecoin. A GPU or graphics card can also be used for mining Dogecoin. For example, Sapphire Pulse Radeon RX 580, Asus RX Vega 64, and many more. Stripped ASIC miner is programmed to mine script-based cryptocurrencies like Dogecoin, like Bitmain Antminer L3, BWL21 script miner, etc. If you are new to Dogecoin mining, then using your PC's CPU will be the right choice, and CPU miner is the most appropriate software. If you are thinking of mining using GPU or graphics card, you can have a wide range of software. Some of the best software is CUDA Miner, which works perfectly with NVIDIA products, CG Miner, which works with most GPU hardware, and Easy Miner is considered suitable for beginners. Stripped ASIC miners are considered to be very powerful hardware, and multi-miner is excellent with this hardware. Moving ahead, let's understand what Dogecoin cloud mining is. Dogecoin cloud mining is a mechanism to mine Dogecoin using rented data centers without installing any hardware and related softwares. It allows people to take an interest and participate in Dogecoin mining at a very low cost, making Dogecoin mining accessible for a broader range of people worldwide. Since the Dogecoin mining process uses the cloud, it reduces equipment maintenance or direct energy cost. This whole concept of Dogecoin mining brings me in front of one question. Is Dogecoin mining profitable? Dogecoin mining profitability can be analyzed based on power consumptions, hash rate, and cost. The Dogecoin mining calculator is used to make it simple in this calculator. The default value for the latest Dogecoin mining hash rate and latest Dogecoin difficulty target is preloaded for better results. Dogecoin mining's reward is $44,44,412.25 per year, that is 14 million Doge per year. The block time for Dogecoin is 1 minute, which means the supply of Dogecoin will never go down. After deducting mining power costs and mining fees, the final daily Dogecoin mining profit is $22.53 Dogecoin to USD with a profit margin of positive 81.72%. Also, I think Dogecoin mining is fun. So that brings us to what is Dogecoin wallet. A Dogecoin wallet is something where you can store, receive, or send Dogecoins. Technically, it is very similar to a real live wallet. Dogecoin wallet consists of its public and private key, connecting it to the distributed ledger over the Dogecoin network. You can use your wallet's public key, which also functions as your coin address, for your bank account number for Dogecoin, where anyone can track the transactions made by maintaining the anonymity of the users. The private key of your wallet is used to approve transactions in the ledger. Your wallet's public key is used to receive Dogecoins from other users. On the other hand, your wallet's private key is only used to send Dogecoins to other users in the network. So what are the types of Dogecoin wallet? Dogecoin wallet is of two types: digital Dogecoin wallet and physical Dogecoin wallet. Digital Dogecoin wallet is accessible through the web, and you can also download it according to your handset or operating system. On the other hand, physical Dogecoin wallets are pretty expensive and less accessible. So moving on, let's see how to create a Dogecoin wallet. To create a Dogecoin wallet for yourself, you will have to go through the following steps. Step 1. Choose the correct wallet. Dogecoin Core Wallet and Multi-Doge Wallet have been created and are maintained by the developers team of Dogecoin. Here, we will be using the Dogecoin Core Wallet as reference. Step 2. Download and install the Dogecoin wallet in your handset. You can also use the official website of this wallet for your Windows. And step 3. Open the Dogecoin wallet application and verify your Dogecoin wallet address. And that is it. It is this easy to create and have your Dogecoin wallet. Now, when you have your Dogecoin wallet in your hand, let's see how you can use it. On the very bottom of the home page of your wallet, there are two options: Request Coins, where you can request Dogecoins from other users in the Dogecoin network, and Send Coins, where you can send Dogecoins to other users in the Dogecoin network. To receive coins, first click on the Request Coins button. Second, enter the required number of coins you want to request. And third, have the below generated barcode scanned by the user you wish to request the amount. Now to send coins. First, type the Dogecoin wallet address to whom you want to send Dogecoins. Enter the required amount you wish to send to that user. And third, click on send. And there you go. Now you can use your Dogecoin wallet whenever and wherever you want. This makes me wonder, why is Dogecoin so popular? Despite being in tough competition with other strong cryptocurrencies like Bitcoin, Dogecoin has never missed an opportunity to be in the limelight. Dogecoin's popularity is mainly attributed to its vast and dedicated community. Other than that, social platforms like Reddit and Twitter also promoted Dogecoin to a great extent due to its fun factor and the whole joke story behind it. Celebrities like Snoop Dogg, Kevin Jonas, Elon Musk also started taking an interest in Dogecoin and posting pictures and comments on their social media handles, which increased the craze of Dogecoin all around the world. So this was all about Dogecoin wallet. Now let's have a look at the top 5 Dogecoin wallets of 2021. These are the top 5 Dogecoin wallets of 2021. Ledger Nano X, Trezor Model T, Kipkey, Binance, and Kraken. Kraken is primarily a cryptocurrency exchange platform but can perfectly act as a Dogecoin wallet. All you need to do is to register and then buy some Dogecoins. It is a very secure and reliable cryptocurrency exchange platform. It charges a very low fees for every transaction taking place on it, and it accepts a pretty decent amount of fiat money. In this video, we will compare and contrast Dogecoin, Bitcoin, and Ethereum based on a few related concepts around these cryptocurrencies. It will help us understand the functioning of these top cryptocurrencies and will also let us figure out the individuality of each one of them. Dogecoin was intended to be an altcoin and a meme coin inspired by Shiba Inu's popular meme, aka Doge. But it was very well received by everyone in the crypto world, and today it is the 4th top cryptocurrency. Dogecoin is a peer-to-peer open source cryptocurrency that provides its users with a completely unknown, decentralized, and secure environment to make their transactions. Bitcoin led the first revolution of digital money in 2013. Bitcoin enables transparent and decentralized peer-to-peer transaction. Bitcoin is designed to be an alternative to national currencies and intends only to be a medium of exchange and value storage. It comprises of features like a public ledger, immutability, and high transparency, making it a great platform. Ethereum came into the picture years after Bitcoin. Ethereum offered a platform to build and run applications without any downtime, fraud, or interference of any third party. Ethereum serves as a computing platform that enables its developers to build and deploy their decentralized applications using smart contracts through its currency Ether or ETH. The primary function of Ether is to help developers build smart contracts using dApps or decentralized applications. Now, let's move on to the comparison between Dogecoin, Bitcoin, and Ethereum. We will be comparing them based on few major parameters like algorithm, programming language, mining process, monetary policies, transactions, today's value, and availability. So let's move ahead and start with the very first comparison, the algorithm. Dogecoin uses strict cryptography for mining the blocks of the Dogecoin network. In comparison, Bitcoin uses the SHA-256 hashing algorithm for mining its blocks in the blockchain network. Ethereum, on the other hand, uses the E- algorithm for mining its transactions. Script language is a password-based key derivation function that is mainly used to avoid customized hardware attacks by raising the resource demands of the algorithm. SHA-256 algorithm helps Bitcoin users protect all their sensitive data like private keys or transaction details and help maintain the anonymity of the user for a much secure performance of transactions. E- algorithm is mainly used during the proof of work function. Proof of work is a small piece of data that is difficult to generate but easy to validate and satisfies specific network requirements. Moving on, the following comparison. Programming language. Dogecoin is considered to be an altcoin for Bitcoin. Both Dogecoin and Bitcoin use the same programming language, C++. It is a stack-based programming language used to give Bitcoin and Dogecoin software instructions on how to make transactions. On the other side, Ethereum uses Solidity, which is a high-level programming language used by Ethereum for implementing smart contracts. Now that we have covered programming language and the algorithm of these cryptocurrency, let's get to the following very important parameter, which is mining process. But before getting started with the comparison, first let's understand what mining is. Mining is a process in which transactions are validated and added to the blockchain public ledger in blocks, and the people mining these blocks are called miners. In terms of the mining process also, Dogecoin and Bitcoin use the same method to verify and validate the pending transaction in their networks, and that is proof of work. Although Ethereum miners also mine the unvalidated transactions using the proof of work method, it aims to switch to proof of stake because it will make its network more immune to centralization, energy efficient, and more vital support for shared chains. Now we have come to the following comparison, which is monetary policy. Monetary policy is known as the process of drafting, announcing, and implementing the plan of actions taken by the competent monetary authority to control the money supply and achieve goals that promote sustainable economic growth. Dogecoin's policy is defined by its block reward paid to its miners, whereas Bitcoin's policy is defined by two processes, halving and block reward. Halving event is when reward of mining Bitcoin is cut in half, and it also cuts the inflation rate. And the block reward is the number of Bitcoins you get if you successfully mine a blockchain block. And Ethereum's policy is defined as minimum issuance to secure the network. That is, there is a constant trade-off between the transaction speed and security. Dogecoin's block reward is 10,000 for mining one block. Bitcoin's block reward is 12.5 for mining each block, and which is set to get reduced to 6.25 by 2024. And Ethereum's block reward is 2 Ether per block. Dogecoin takes 1 minute to generate one block. Bitcoin takes 10 minutes to generate one block. And Ethereum generates one block every 14 seconds. Well, monetary policies are considered to be fixed and non-inflationary. Due to this, over time, mining blocks will become more complex. Now, moving on to the following comparison, which is transactions. Dogecoin is the fastest and can complete 70 transactions in 1 second and takes just 2 to 3 minutes to confirm a transaction. Bitcoin can complete up to 5 transactions in 1 second and takes 10 minutes or more than that to confirm one transaction. And Ethereum can complete 30 transactions per second and it takes just a few minutes to confirm it. Dogecoin is majorly used for tipping content creators on social platforms like Reddit and Twitter. Bitcoin is only used as a superior alternative for fiat money and is used primarily for real-world transactions. On the other hand, Ether, the currency of Ethereum, acts as the fuel for Ethereum networks. Now that we have covered all about transaction process of these cryptocurrency, let's have a look at the value of Dogecoin, Bitcoin and Ethereum in today's date. The value of Dogecoin on today's date is $0.2992. Bitcoin being the highest is 34,857.58. And Ethereum holds a value of $2,356.58. Now we have reached the last comparison of Dogecoin, Bitcoin and Ethereum, which is availability. The circulating supply of Dogecoin is 127 billion. Bitcoin, very low as compared to Dogecoin, is just 21 million in circulation. Ethereum, on the other hand, is said to be unlimited, but till today, the circulation supply of Ethereum is 115.6 million. Till today, 113 billion Dogecoin has already been mined. For Bitcoin, 18 million Bitcoins are already mined. And for Ethereum, roughly 36 million Ethereum has already been mined. In this graph, you can see the red box on the right side of the graph shows the maximum supply of Dogecoin. On the extreme left, you can see first the options that you can use according to your requirements. Like if you want to know about Dogecoin, you can go for the first option, that is www.dogecoin.com, which will lead you to the official website of Dogecoin. If you want to chat with the executives of CoinMarket regarding Dogecoin, then you can go for the fourth option, which is chat. Before that is an address for Binance address, through which you can keep a track of Dogecoin's value on that platform. And you can also change it according to your choice by clicking on More. Right beside the More option, you can see the market cap value of Dogecoin, which is 38,349,469,098. It is the total value of Dogecoin in circulation. Beside the market cap option, you can see fully diluted market capitalization, which is 38,700,795,906. It is the capitalization when max supply of Dogecoin was in circulation. And on the right side, just before total supply, you can see the volume of Dogecoin, 1,779,417,647. It is the value of Dogecoin traded in 24 hours. Next is Bitcoin. Similar to Dogecoin, you can see the red box on the right side of the graph shows the maximum supply of Dogecoin. On the extreme left, you can see first the options that you can use according to your requirement. Like, if you want to know more about Bitcoin, you can go for the first option, that is www.bitcoin.org, which will lead you to the official website of Bitcoin. Right beside the More option, you can see the market cap value of Bitcoin, which is 651,713,010,753. It is the total value of Bitcoin in circulation. Beside the market cap option, you can see fully diluted market capitalization, that is 732,387,262,690. And on the right side, just before the total supply, you can see the volume of Bitcoin, that is 30,249,939,865. Ethereum is no different from Dogecoin and Bitcoin. In this also, you can see the total supply of Ethereum. Also, you can visit the official website of www.ethereum.org to explore more about Ethereum. You can have a look at the market cap value of Ethereum, which is 273,755,586,534. The fully diluted market capitalization is 273,576,987,049. The volume of Ethereum traded in 24 hours is 24,101,779,346. But in the end, all these top cryptocurrencies, Dogecoin, Bitcoin and Ethereum, share a few similarities. Like, they all are decentralized. All three cryptocurrencies are free from any third-party interference or any centralized authority, and can be used to have secure and independent peer-to-peer transaction, maintaining the anonymity of the user. And proof of work, that is, all their transactions are verified and validated before processing. After complete verification, further transaction process takes place. Also, all of them have a large network of independent nodes.
Let's get started and understand what kind of interview questions can come for a blockchain interview. So let's start with certain beginner level questions. Now, when you face a blockchain interview, you can get different variety of questions. So we will be covering that what kind of questions can be asked at each level, beginner, intermediate and expert level. So one of the few questions which you could be asked is, what is the difference between blockchain and Hyperledger? Blockchain is basically the underlying concept. Blockchain is a decentralized technology of immutable records called blocks, which are secured using cryptography. Whereas Hyperledger is a platform or an organization that allows people to build private blockchain. So basically, blockchain is a concept, is a technology. Using blockchain, you can build public and private blockchains, but Hyperledger is a specific technology which allows you to build only private blockchains. Now, blockchain is divided into public, private, and consortium blockchains. Hyperledger is specifically a private blockchain technology where the access to blockchain data is limited to predefined users and it is defined using certain configurations and programming. Blockchain can be used in multiple fields like business, governments, healthcare, other different kind of domains, and etc. Hyperledger is primarily used in blockchain for enterprise-based solutions. So wherever we are talking about public blockchain, it is like usage of blockchain on internet, and Hyperledger-based blockchain solutions are solutions which are meant for intranet within an organization, within a corporation. Second, how do you explain blockchain technology to someone who doesn't know it? So basically, in simple terms, blockchain technology is a distributed ledger which stores transaction details in the form of immutable records, non-modifiable records, which are called blocks, which are secured using cryptography. So in order to explain simplistically, let's consider an example of a school where blockchain is similar to a digital report card of a student. Now, each block contains students' records which has a label stating the date and time of when the record was entered or when the record was registered on the blockchain. Now, neither the teacher nor the student can modify the details of that block, cannot modify the record of report cards. Therefore, the record becomes non-modifiable, immutable. Also, the teacher owns a private key that allows him or her to make new records, and the student owns a public key to view and access the report card at any time. So basically, the teacher owns the right to update the record, but the student only owns the right to view the record. Now, this method makes the data both accessible and secure. And this is what blockchain brings on the table. These are the primary attributes for which blockchain is getting widely adopted, to have immutable records available for view to the public and available for updating in an untamperable way. Now, what is a Merkle tree? Merkle tree is a data structure which is used for verifying a block. It is in a form of a binary tree containing cryptographic hashes of each block. So basically, a Merkle tree is structured similar to a binary tree. Each leaf node is a hash of a block of transactional data. So each leaf node is basically a transaction which is hashed, and each non-leaf node is a hash of its leaf node. So basically, hash AA is the hash of two blocks, hash A and hash B. Merkle root or the hash root is the final hash of all the transaction hashes. So basically, Merkle root is the hash of hash AA and hash BB. So it encompasses all the transactions which are underlying all the non-leaf nodes. What do you mean by blocks in the blockchain technology? What is the definition of a block? So blockchain is a distributed database of immutable records called blocks, which are secured using cryptography. Now, as you see, there are the certain attributes of a block which are displayed here. You have previous hash, transaction details, nonce, and a target hash value. So a block is like a record of transactions. Each time a block is verified, it gets recorded in chronological order on the main blockchain. So as you can see, as it is represented over here, every time a new block is verified, it gets added to the main blockchain with all those attributes populated. Now, once the data is recorded, it cannot be modified, it cannot be changed. Now, another question which would come into your interview is, how is blockchain distributed ledger different from a traditional ledger? It is a very important question. We need to know the basic difference and justification if we have to move from a traditional database to a blockchain based distributed ledger. What benefit it brings on the table? So certain differences which are very visible are transparency. Blockchain distributed ledger is highly transparent as compared to traditional database. Distributed ledgers are irreversible. Once any information is registered on a distributed ledger, cannot be modified, whereas on a traditional ledger it is reversible basically. Distributed ledger is more secure. It uses cryptography. Every transaction is hashed and recorded. In a traditional ledger, the security can be compromised. In a distributed ledger, there is no central authority. It's a distributed system. The participants of the network holds the authority to maintain the sanity of the network and are responsible for validating the transactions. Whereas traditional ledgers are based on the concept of centralized authority and control, and all the transactions are controlled by the centralized authority. In a distributed ledger, identities are unknown and are hidden. Whereas in a traditional ledger, identities of all the participants have to be known before the transaction can happen. In a distributed ledger, there is not a single point of failure. As the data is distributed, information is shared across multiple nodes. Even if a single node fails, the other nodes carry the same copy of the information. Whereas in a traditional ledger, in a centralized database ledger-based system, that particular system becomes a single point of failure. If the single system crashes, the entire application or the entire network comes to a standstill. Ability to modify data? No. Once the data or a transaction is registered, it cannot be altered. In a traditional ledger, it is possible. How validation is done? So in a distributed ledger, it is done by the participants of the network. In a traditional ledger, it is controlled by the centralized authority. Copy of ledger is shared amongst all the participants of a distributed ledger. Each participant consists the same information in the ledger. In a traditional ledger, only a single copy is maintained at a centralized location. It is not shared amongst all the participants. Thereby, again, it remains as a single point of failure. If you have any queries, you can put your comments in the comment section of this video and we will definitely come back to you. How can you identify a block? What are the attributes of a block in order to understand it? So every block consists of 4 fields. It holds the hash value of the previous block. Therefore, it gets linked in a blockchain. It contains the details of the aggregated transactions which are aggregated in the block. It has a value called nonce. Nonce is a random value which is used to vary the value of the hash in order to generate the hash value less than the target. And then finally, you have a hash of the block itself. It is the digital signature of this block, a unique hash for this block. It is an alphanumeric value which is used to identify a block. So that is the identity of the block. The hash address is the unique identification of a block. It is a hex value of 64 characters that has both letters and digit. It is obtained by using SHA-256 algorithm. Now this is the way it is structured. The hash of the previous block, the transaction data and the nonce consolidate the header of the block. They all together are passed through a hashing function and then the hash value, the digital signature of the block is then generated. What is cryptography and what is its role in blockchain? Blockchain uses cryptography primarily to secure users' identities and ensure the transactions are done safely with a hash function. So all the user identities and the transaction on a blockchain are encrypted. Cryptography uses public and private keys to encrypt and decrypt data. So basically it uses the public and private key infrastructure in order to maintain the encryption of the information on a blockchain network. In blockchain network, public key can be shared with all the Bitcoin users, all the blockchain users. So public key is just like your address, which you can share it with anyone. But a private key is like your password. It is kept secret with the user. So basically, blockchain uses cryptography to secure user identities and ensure transactions are done safely. And how does it do it? It uses SHA-256 algorithm, which is secure, which provides a unique hash output for every input, and it is a very popular algorithm. The basic feature of SHA-256 is that whatever input you pass, it will give you a standard output, alphanumeric output of 64 characters. So basically it is a one-way function. You can derive an encrypted value from the input, but you can't do vice versa. Now, what are the different types of blockchains which exist? There are three different types of blockchains: public blockchain, private blockchain, and consortium blockchain. Public blockchain, ledgers are visible to all the users on the internet, and any user can verify and add a block of transactions to the blockchain. Basically, it's publicly available. Anyone can participate in the network and get hooked up. So examples are Bitcoin and Ethereum. Private blockchain ledgers are visible to all the users on the internet, but only specific users in the organization can verify and add transactions. So it's a kind of a permissioned blockchain, though the information can be available publicly, but the controllers and the validators of the blockchain are within the organizations and are predetermined. The example is Blockstack, consortium blockchain. Here, the consensus process is controlled by only specific nodes. However, ledgers are visible to all the participants in the consortium blockchain. Example is Ripple. Now, what happens when you try to deploy a file with multiple contracts? In blockchain, deploying a file with multiple contracts is not possible. The compiler only deploys the last contract from the uploaded file, and the remaining contracts are neglected. And this is the way a smart contract is deployed on a blockchain network. Now, very interesting question. What is a Genesis block? It's a very important question and could be asked in an interview multiple times. So basically, Genesis block is the first block in the blockchain, which is also known as block 0. So as you can see, the sequence number of this block is 0. And in blockchain, it is the only block that does not refer to any previous block. So the hash value of the previous block will be all zeros because it is the first block. Also, it defines parameters of the blockchain such as level of difficulty, consensus mechanisms, etc. to mine the block. So basically, it defines the primary attributes of the blockchain which is going to get initiated from the Genesis block onwards. Now let's look at some of the questions which would come if you are at an intermediate level. Now, how is the hash of a block signature generated? In blockchain, to generate a digital signature, transaction details are passed through a one-way hashing function, for example, SHA-256. Then, the output value is passed through a signature algorithm like ECDSA with the user's private key. Then, the encrypted hash along with the other information such as the hashing algorithm is called as the digitally signed document and is called the digital signature. So this is the entire process of generating a digitally signed block. List down some of the extensively used cryptographic algorithms. These are the few popular algorithms which are extensively used. SHA-256, Bitcoin uses it. Ithash, Ethereum uses it. RSA is one of the other popular algorithm. Blowfish, DDES. So it's very important to memorize these algorithms, the names of these algorithms when asked, and SHA-256 and Ithash are used in two of the popular public blockchain networks. What is a smart contract, and list some of its application? So smart contracts are self-executing contracts. These are basically digital contracts which contains the terms and conditions of an agreement between two parties, between two peers. Now, some of the applications can be used in transportation where shipment of goods can be easily tracked using smart contracts. So as there's a movement of goods and it is exchanging hands between different parties, there could be need of a contract and a smart contract between the parties. It is also used in protecting copyrighted content like music or books or the literature which you have written. So smart contracts can protect the ownership rights. It can also be used in insurance. It can be used to identify false claims and prevent forgeries. Employment contract, smart contracts can be helpful to facilitate wage payments, and it can be used as a proof of employment. Now, another important question, what is Ethereum network and how many Ethereum networks are you familiar with? Ethereum is a blockchain-based distributed computing platform featuring smart contract functionality that enable users to create and deploy their decentralized applications called dApps. There are three types of network in Ethereum. live network, the mainnet. Then there are a couple of test networks like Ropsten, Coven, and Rinkeby. And then you can also create your own private network using Ethereum. Smart contracts are deployed on the main network. They are publicly available and can be used by others also. Test networks allows you to run your smart contracts on a test net, validate the gas which is being used. You can just use these test networks as the main net, deploy your contracts, verify your decentralized application, and then move on to the main net. Private networks are those which are not connected to the main network, which run within the premises of the organization but carry the features of an Ethereum network. Now, where do nodes run smart contract code? Nodes run smart contract codes on a Ethereum virtual machine. It is a virtual machine designed to operate as a runtime environment for Ethereum based smart contracts. EVM is operated in a sandbox environment or isolated from the mainnet, and it is a perfect testing environment. So you can download the EVM, run your smart contract locally in an isolated manner, and once you have tested and verified it, then you can deploy it on the mainnet. Now, a very important and a very good question. What is a dApp and how is it different from a normal application? We need to understand these differences very thoroughly in order to clear our interview. So a dApp is a decentralized application which is deployed using smart contract. The information on a dApp is distributed and shared. In a normal application, it has a centralized database which is running on a centralized server. So you have a single server and a single code which is maintaining the entire application. No information is shared and it is a single point of failure. A dApp has its backend code, a smart contract which runs on a decentralized peer-to-peer network. In a normal application, it's a typical computer software application that is hosted on a central server. So if we see in the differences in the process, you have a front end, then in the middle, you have a smart contract which is acting as the backend code, and then the entire transaction executed on a smart contract is shared between the blockchain participants in a P2P network. Whereas in a normal application, the front end interacts with a centralized API which performs basic CRUD operations, create, read, update, delete on a centralized database, and it is a single copy of the information. Name some leading open source platforms for developing blockchain applications. So Ethereum is one of the popular platforms for building blockchain based applications, and it is widely getting adopted. Eris is also used for building enterprise based solutions, and also some of the widely used platforms for building blockchain are listed below. Hyperledger, multi-chain, open chain are available in the market. What is the very first thing you must specify in a Solidity file? Now it is necessary to specify the version number of Solidity at the beginning of a code, as it eliminates incompatibility errors which can arise while compiling with another version. It is a mandatory clause which has to be there at the top of any Solidity code which you write, and you need to mention the correct version number for which you have written the code. Now, what is the difference between Bitcoin and Ethereum? And it's a very important question which I also ask in a lot of interviews, and it's important for you to remember these differences. So Bitcoin, the concept is purely P2P currency based transaction, but in Ethereum you can do both P2P currency transaction plus you can deploy smart contracts. Bitcoin is primarily working on proof of work consensus mechanism. Ethereum is shifting from proof of work to proof of stake. Bitcoin uses SHA-256 hashing algorithm, whereas Ethereum uses ithash. Time taken to mine a block currently on Bitcoin is approximately 10 minutes, whereas in Ethereum it gets processed in 12 to 15 seconds. The reward for mining on Bitcoin as of today is 12.5 Bitcoin, whereas in Ethereum it is 3 Ethers plus the transaction fees. On Bitcoin, the transaction fees are optional, whereas in Ethereum the fees is calculated based on the gas which is being consumed on a smart contract per transaction. Value of Bitcoin as of 21st August was captured at $6,934 US, whereas Ethereum stands at $278. Now, what is nonce and how is it used in mining? In blockchain, mining is a process to validate transactions by solving a difficult mathematical puzzle called proof of work. Now, proof of work is the process to determine a number, a nonce, that is the number, along with a cryptographic hash algorithm to produce a hash value which is lower than a predefined target. Nonce is a random value which is used to vary the hash value so that the final hash value meets the hashing condition. So the nonce is the value which is being generated by the miner in order to guess the hash value which should be less than the target value. And then only the miner can claim the reward for if he's mining a Bitcoin network of 12.5 BTC and a Ethereum network of 3 Ethers. Now let's look at some of the advanced level questions. Name the steps that are involved in a blockchain project implementation. So in a typical blockchain-based project implementation, we start off with requirement identification. We need to understand the problem and goal. We need to identify the suitable consensus mechanism. What is the most suitable platform which can solve the problem? And then identify the implementation and deployment costs. We need to give an ROI to the client. Then we move on to the planning stage. In this step, an individual evaluates all the requirements, lists them down, prioritize them, and decides a suitable blockchain platform which has to be used to implement this particular problem. Then kicks off the development and implementation of the project. You design the architecture, you design the user interfaces, and start building the APIs. And then comes controlling and monitoring the project. You apply the proof of concept, you start off with that and then start building the application on top of it. And then once the basic version of the application is available, you start identifying bugs and start fixing them. Explain a real life use case where blockchain is being used. So supply chain is the biggest adopter of blockchain. And as you can see, as the raw material is exchanged between different entities in a supply chain, the traceability of that particular digital asset, which in this case is raw material, is a big case study on blockchain. In supply chain management, smart contracts provide permanent transparency, traceability, and validation of transactions shared by multiple supply chain partners. So at each level, each supply chain partner has to register a transaction when it receives a product and then when it passes it on. So basically, the purchaser, when consuming the end product, can see the entire journey of the product. List and explain the parts of EVM memory. So the memory of an EVM is divided into 3 parts: storage, memory, and stack. Storage values are stored permanently on the blockchain network and it is extremely expensive. So whenever you will try to modify a storage based variable, you would have to pay gas for it. Memory variables are temporary modifiable storage area. It can be accessed only during the contract execution, and once the execution is finished, the data is wiped off, vanished, and it's lost. Stack, on the other way, is a temporary and a non-modifiable storage. Here, when the execution is completed, the content is lost. So basically, memory and stack are relatively much cheaper than storage variables. Now, what happens if the execution of a smart contract costs more than the specified gas? Initially, your transaction will be executed, but if the execution of a smart contract costs more than the specified gas, then the miners will stop validating your contract. The blockchain will record the transaction as failed, as highlighted, and also the user does not get a refund. So it becomes of utmost importance that when you are deploying your smart contract, you do the calculation of the gas consumption in the most correct fashion. What does the gas usage in a transaction depend on, and how is transaction fee calculated? So gas usage depends upon the amount of storage you are using. If you're using storage based variables, and the cost of the transactions will be high, the gas will be high. And the set of instruction codes used in a smart contract. Basically what operations you are performing on the storage based variables, either they're costly, and if you are using huge amount of storage variables, then automatically the cost of your smart contract will keep on increasing. So basically the transaction fee is calculated in ethers, which is given as the gas price which you have determined for your smart contract and multiplied by the gas limit. And this is how your transaction fee is evaluated. Now, what is fork and what are some of the types of forking? So in simple terms, updating a cryptocurrency protocol or code is called forking. Fork implies that a blockchain splits into 2 branches, and forking is done when you want to modify certain attributes of an existing blockchain network. It can happen when the participants of the network cannot come to an agreement with regards to either the consensus algorithm or they want new rules for validation. So there are 3 types of forking: hard forking, soft forking, and accidental forks. What is the difference between proof of work versus proof of stake? And it's a very important question. In blockchain, proof of work is the process of solving a complex mathematical puzzle called mining. Whereas proof of stake is an alternative proof of work by which the blockchain aims to achieve distributed consensus. In proof of work, probability of mining a block is based upon the amount of computational work done by a miner. Basically, it consumes huge amount of resources, electricity, resources and computational resources of the miner. Whereas in proof of stake, the probability of validating the block relies upon the amount of token you own beforehand. So the more the tokens you have, the more the chance you get to validate a block. So basically, proof of stake has been introduced in order to reduce the pressure on the resources which has been put by the proof of work consensus algorithm. Miners spend a lot of computing power for solving the cryptographic puzzle along with the hardware, and it's a huge cost. So basically, proof of stake was created as a solution to minimize the use of expensive resources spent in mining. What is a 51% attack? In blockchain, 51% attack refers to a vulnerability where an individual or group of people can control the majority of the mining power or hash rate. So basically, they can take over the 50% of the blockchain network. This would allow the attackers to prevent new transactions from being confirmed. Further, they can double spend the coins. Now, in 51% attack, smaller cryptocurrencies are primarily being attacked, which does not have a huge network, which has a small consumer base. What are function modifiers in Solidity, and mention the most widely used modifiers? In Solidity, function modifiers are used to easily modify behavior of your smart contract. It can be associated with a function, and then whenever a function is called, the modifier is called before the main function. In simple terms, it can build additional features or apply restrictions on the function of smart contracts. The most extensively used function modifiers in Solidity are view. View functions are functions that cannot modify the state of a smart contract. They are only read-only functions. Here is an example. You have a function get Simplilearn name, and it is having a modifier view which only returns a value, but you are allowed to use some inbuilt Solidity functions like msg.sender. But in case of pure functions are functions that neither read nor write the state of smart contracts. They return the same result determined by its input variables. So basically, you can't even access the inbuilt functions of Solidity. So here you have a function called calculate. You can only use the input variables. You cannot use any of the inbuilt functions also of Solidity. Now let's take a look of an example. In order to write a crowd sales smart contract code in Solidity programming language. So here in the example, you have a smart contract where you have defined certain smart contract variables of Solidity like address and uint. Now the address function is if you want to send your token to someone, and your uint is the funding goal in ethers, basically how much amount of ethers you want to generate in your crowd sale project. Then what is the duration of your project, then cost of each token in ethers, then address of token used as reward. So these are the primary attributes which you have defined. Then you have your public functions which are defined over here. The beneficiary if successfully sent to, the funding goal, the deadline of your crowd sale, and the price. Now here is your default function which is defined in a Solidity contract which does not have any function name and is called by default in your smart contract if anyone invokes a method in your smart contract which does not exist. In this function, you are making sure that all the amount which has been passed to the smart contract is passed to your address. Basically, you are the originator of your crowd sale function, crowd sale smart contract. So you should be receiving the amount. Then in your crowd sale smart contract, you can have a method which is called as safe withdrawal, and you have appended it with a modifier called after deadline. So which basically checks that you can only do a withdrawal after the deadline has been achieved. And in this function, you are checking the balance, then you are withdrawing that amount from the sender and transferring it to your own account as the sender has sent that amount to you. So you do the basic validations, whether the sender has that balance, and then you do that transfer to your account.
And with that, we have come to the end of this video on Blockchain Developer Full Course. I hope you find it informative and interesting. If you have any questions about the topics covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Thanks for watching, stay safe, and keep learning.